We all agree that the environment and economy are two sides of the same coin. If we cannot sustain environment, we cannot sustain ourselves. Esteemed guests, distinguished speakers, experts from industry, ladies and gentlemen, a very good afternoon to all of you. My name is Ethanol Economy. I will be your host for this webinar. On behalf of International Center for Automotive Technology, let me extend a warm welcome to all of you for joining this webinar on ethanol economy. This event is an initiative by Aspire Technology Platform from ICAT. Aspire stands for Automotive Solutions Portal for Innovation, Research and Education. Aspire aims to support the technological innovation and collaborative research which is initiated for the Atmanirbhar Bharat mission and direction from Department of Heavy Industry, Government of India. It is our privilege to have you all for today's webinar. And this webinar is a part of the celebration of Azadi Ka Amrit Mahotsav on the occasion of 75th anniversary of Indian independence. Through this webinar, we have set a virtual stage to build awareness through the insights by the industry experts. Let us indulge and acquaint ourselves with the progress ethanol has played so far and the role of ethanol can play in the growth story of our country's economy. So, ladies and gentlemen, for this inaugural ceremony, it is my pleasure to extend a cheerful welcome to our guests of honor, Dr. S.S.V. Ramakumar, Director R&D, IOCL, Dr. Reggie Mathai, Director ARAI, Mr. C.V. Raman, CTO Maruti Suzuki India, Mr. Vikram Kasbekar, Executive Director and CTO Hero MotoCorp. We have with us esteemed presence of Shri Dinesh Tyagi, Director, International Center for Automotive Technology, Srimati Pamela Tikku, Senior General Manager, International Center for Automotive Technology. I want to extend my heartfelt thanks to all the dignitaries for gracing the occasion with their kind presence. With this, I would like to request Shri Dinesh Tyagi, Director ICAT, for the welcome address for the inaugural ceremony. Sir.
You are on mute.
Yeah, thank you, Enoch. Can you hear me now?
Yes, sir, you're audible. Yes.
All right, thank you. A very good afternoon and warm welcome to all of you on behalf of ICAT at this webinar on ethanol economy. It's indeed my pleasure to have with us this esteemed panel for the inaugural session. I extend a very warm welcome to our guests of honor and to all other participants at this session. Dr. S.S.V. Ramkumar, Dr. Reggie Mathai, Mr. C.V. Raman, Mr. Vikram Kasbekar, my colleague Pamela, dear friends and colleagues from the Indian automotive industries, ladies and gentlemen. On the occasion of the World Environment Day, 5th June 2021, Honorable Prime Minister of India has released the report of the Expert Committee on the Roadmap for Ethanol Blending in India 2020-2025. The committee has suggested a roadmap for the production and supply of ethanol blended petrol. Several key recommendations have been made in this report to increase and augment the production capacity and utilization of ethanol blended petrol. These steps will help in curbing the pollution levels and also in saving revenues used for import of the petroleum products. As per the report, successful adoption of E20 fuel can save an estimated over 30,000 crores of Indian rupees annually in its petroleum import bill. The expert committee has expressed hope that the target of 20% ethanol blending of petrol can be achieved by the year 2025 in the country. It has recommended that sugarcane and grain-based ethanol production capacity shall have to be augmented to achieve this target. The hope of ethanol production from bamboo stock also provides a big hope to this initiative. We are all aware of the Atmanirbhar Bharat mission of our Prime Minister, and that can be supported through this initiative, as there is a 100% possibility of local procurement of ethanol. With this successful implementation, not only there will be improvement in India's energy security status, but also a reduction in import dependency and reduction in carbon emissions, hopefully. However, there are several challenges in front of the oil industry that I can foresee for its successful implementation, such as notifying ethanol blending roadmap in a phased manner, augmenting the requisite production, logistics and delivery infrastructure in a phased manner, expediting regulatory clearances, and the pricing, of course, of the blended gasoline. Niti Aayog committee report states that vehicle manufacturers are expected to ensure 1. E20 compliant and E10 tuned new vehicles are rolled out all across the country from April 2023. These vehicles should be able to tolerate gasoline blended with 10% to 20% of ethanol, and also to be able to give an optimal performance with even E10 blend. Number 2, vehicles with E20 engines should be rolled out all across the country from 2025 onwards. And these vehicles would run on E20 only and deliver high performance. While E20 blend is a fuel, has about 7% lower calorific value than gasoline, it has a few other favorable considerations, such as higher octane number. The RON value of ethanol is in between 120 to 130, which provides an opportunity for higher compression engines, thus enabling a powerful compact engine. Another thing is the favorable stoichiometric ratio for E20, which is about 13.5 and which is about 20% better. It's lower, so it's better than pure gasoline. So overall, E20 fuel may, I'm saying may, provide a positive benefit in engine sizing and also the power output if the engineering work has been done optimally. However, to achieve these objectives, there are several challenges in front of vehicle manufacturers, such as number 1, optimization of the engine tuning, so-called, making the vehicle ethanol compatible with respect to the notified roadmap for higher ethanol blends, and holding with vendors to develop ethanol compatible parts, and to conduct the entire process of validation, testing, durability studies on engines, and also the field trials before introducing E20 compliant vehicles. Logistics issues if the vehicles are manufactured in a phased manner as the blending progresses. Making ethanol compatible vehicle available at the locations where blended fuel is available and other way around. Also to face challenges with E20 fuel in older vehicles if somebody fills it. Subject of incentivizing ethanol blended vehicles. The challenges of the timing and the capacities for engineering work together with pending phases of already CAFE and BS6 implementation. So some phases are to be done. So lots of engineering work will have to be done by them within a few years, couple of years. I'm confident that these points will be discussed today in the first session, and we are ready to partner with oil companies and automobile manufacturers for joint research work, especially in the areas of performance evaluation, validation at both engine and the vehicle levels, and also at component level, in order to support them to face these challenges. With the testing facilities available at ICAT, we can support the manufacturers in the following areas, such as to study the effect of blending versus the fuel economy, comparative studies of gasoline and ethanol blended fuels related to performances and endurances, study of engine efficiency and of emissions, and any other customized study that anyone wishes to jointly conduct with us. MORTH has already issued notification GSR 156E dated 8th March notifying E20 ethanol blend as a reference fuel for M, N, and L categories of vehicles. We will be providing further inputs to MORTH for the formulation of regulations and inclusion of ethanol in standards. ICAT's current facilities are suitable for testing engines and vehicles for the regulated and notified pollutants such as the carbon monoxide, hydrocarbons, and nitrogen oxides. However, it has been reported that unregulated carbonyl emissions such as acetaldehyde emissions were higher with E10 and E20 as compared to normal gasoline due to the presence of hydroxyl group in the ethanol. As the blending increases, such pollutants could also become higher. We will need to assess the environmental effects, and our test facilities may need to be upgraded if such a regulation is reinforced in future. Testing protocols and future regulatory requirements for such pollutants also need to be assessed. I wish this webinar a grand success and hope that the deliberations and discussions during these 2 days shall benefit the participants significantly. Thank you for your patient listening. Jai Hind.
Thank you, sir. Thank you for flagging off this webinar with an enlightening inaugural address, and for all your support in organizing and guiding us for this webinar. Now for the keynote address, let me now take an opportunity to introduce Dr. SSV Ramkumar. He is Director, Research and Development on the board of Indian Oil Corporation Limited. And he has a doctorate in chemistry from IIT Roorkee. And Dr. Ramkumar has almost 3 decades of uninterrupted R&D experience in downstream hydrocarbon sector, notably in the areas of refinery process research streams, including catalyst development, simulation and modeling, and quality upgradation and marketing coordination of automotive lubricants. And Dr. Ramakumar has to his credit over 95 research publications in peer-reviewed national international journals and 33 patents, besides several prestigious awards. We are honored by your presence today, sir. And may I request Dr. Ramkumar to kindly address us.
Thank you very much for this kind words of introduction. Mr. Dinesh Tyagi, I must thank for inviting me to be part of this very topical subject. I mean, a seminar with a very topical and timely theme of ethanol economy. Distinguished panelists on this inaugural session and all the other participants who joined through web. Very good afternoon to all of you. So as Mr. Tyagi has set the tone for the webinar, there is a lot of buzz after Honorable Prime Minister has launched the Ethanol 20 blending roadmap on 5th of June, World Environment Day, based on the expert report submitted by Niti Aayog. I had the privilege of working on this expert committee, and in fact, I am one of the co-authors of the report which was unveiled by Honorable Prime Minister on 5th of June. So, ethanol blending program as a national campaign started almost 2 decades back with varying percentages of blending mandate given from time to time to oil marketing companies with all the perceived benefits of reducing the crude oil import, reducing the hydrocarbon consumption, at the same time preserving the environment by reducing the emission footprint from hydrocarbon combustion. But for almost 2 decades, for want of sufficient and adequate quantity of ethanol, there existed a huge gap between the blending mandate and the actual percentage of blending of ethanol on a national basis that the oil marketing companies achieved. Against a mandate of 10% of blending, till very recently, almost 2 years back, the actual blending average hovered at, rather languished at 3 to 4% only. And but things started changing towards positivity, because ethanol availability was always linked, as long as ethanol is sourced from only so-called first generation sources like sugarcane molasses, it is always linked with the sugarcane crop production. And in our country, we have seen, unlike advanced countries, are often when ethanol comes, Brazil and ethanol are inseparable. Compared to Brazil's agrarian footprint, Indian sugarcane production, crop production, is always been cyclical. 1 year it used to be a bumper crop, and the other year it used to diminish. So the sparable ethanol for blending purposes in transportation fuel was very, very limited, and that's how this poor blending percentage. But then there was a national biofuel policy which was brought out by Ministry of Petroleum and Natural Gas in the year 2018, and especially the policy centered around augmenting the ethanol production in the country, so that adequate quantities of ethanol will be made available for blending purpose in transportation fuel. And that's how the concept of second generation ethanol, production of second generation ethanol technologies. Nowadays, we are also talking about third generation ethanol technology. I'll briefly mention what they are in this. So today, let me share the oven fresh figures from PPAC of Ministry of Petroleum and Natural Gas. Today, right now, current year, the blending percentage is as high as 8.5, which is at a historic high as far as ethanol blending program in this country is concerned. And Ministry of Petroleum and Natural Gas and all oil marketing companies like ours, they are extremely confident that by the end of this calendar year or this financial year, we are going to reach the national average of 10%, which is the current mandate of HEV. So in terms of absolute quantities, if you see, right now the ethanol that is being blended is 300 crore liters, whereas for fulfilling the 10% mandate, you require 400 crore liters. So there is a 100 crore liter ethanol deficit even today, but which we are going to bridge this. Now moving forward, in 2018, this E20 BIS specification has come into force as IS 17021. So by stretching these calculations for fulfilling the E20 mandate, given the current petrol consumption in the country, and also taking into consideration the growth trajectory of MS in the country at a healthy 5 to 6%, even in the midst of this pandemic situation, it is going to be anywhere between 39 million metric tons. MS consumption by 2025, which is the mandated year, it is going to be 39 million metric tons. And what you require to fulfill the 20% blending mandate is 1,000 crores, 1,000 crore liters of ethanol. So the gap to be bridged from the current 400 crores of liters to 1,000 crores of liters is additional 600 crores liters. So how the industry is gearing up? Industry is gearing up, as Mr. Tyagi also briefly mentioned, as a part of this national biofuel policy. Now, the government has announced that the surplus food grain and rotten food grains, which are going as a waste as per the TIFAC figures, which is the authentic source of the data, which are just going as waste, they can be diverted now. Hitherto, they were not allowed to be diverted for ethanol production, but now government has permitted that these rotten food grains or surplus food grains, after meeting the minimum storage levels of the food grains, can be diverted into fermentation process and thereby production of ethanol. In fact, all state-owned oil companies, both oil and gas companies under the aegis of Ministry of Petroleum and Natural Gas, we were assigned to set up these first generation ethanol plants. These are still first generation ethanol plants. Producing ethanol from food grain or sugarcane molasses is known as a first generation technology, just simple fermentation of these feedstock into ethanol and then purification. So let me share with this audience that coming from the oil industry, from the largest oil company attached to Ministry of Petroleum and Natural Gas, collectively all the oil and gas companies, they have decided and they were assigned to set up 14 new biorefineries, first generation biorefineries by 2024, and they would bring in 171 crore liters additional ethanol through first generation route by diverting the surplus food grain or rotten food grain from the FCI or from the local sources. And various geographies are already been identified. Each company is working to fastly commissioning these biorefineries. Apart from that, government under PM Jeevan Yojana, they also assigned that all the three big state-owned oil companies, they need to set up 12 biorefineries to produce ethanol from second generation pathways. Second generation pathways are agricultural residues, lignocellulosic biomass to be scientifically correct, coming from all the crop residues and wheat straw, paddy straw, cotton straw, from these. So the first 2G ethanol plant is going to be commissioned by the end of this year at our Panipat refinery, which is 300 ton per day plant. So second generation ethanol also is going to add up to the ethanol reserves. So collectively, we are all addressing this this imperative of adequacy of ethanol availability for fulfilling the mandate of E20, and we are extremely confident by 2025 on pan-India basis we would be in a position to blend 20% of ethanol in the MS. Whatever MS that we are going to produce, it will be E20. There is a third generation technology pathway also I briefly mentioned. That is very few people are pursuing that in the world, and we are the first one in the country. Indian Oil is the first one in the country. We are converting the carbonaceous emissions emanating out of refineries through biotechnological pathways to convert them into ethanol. Even that plant, we have a very huge plant getting constructed that is also going to be commissioned again at Panipat by the end of this year. So I would just like to assure those representatives from automobile industry that ethanol availability is going to be there to fulfill the E20 target. In fact, DFPD, government's department, their projection indicates that 1,500 crores of liters of ethanol would be available by 2025. 875 crore liters would be from sugarcane molasses, and 625 crores would be available from the grains, surplus grains. And this second generation ethanol would be not a very big percentage, but it would be a smaller percentage. So that is what all the oil marketing companies are proactively working on, setting up additional tankages at their terminals to receive this additional quantity of ethanol. And my R&D center, along with Indian Institute of Petroleum, Dehradun, and ARAI, some 5 years back, we have conducted an elaborate study on E20 blends and their performance in various vehicles, in BS4 vehicles. And definitely there are challenges. From the engine viewpoint, there are challenges. There is a challenge of material compatibility. There is a challenge of engine compatibility. There is an issue of energy debit. I think most likely Dr. Mathai and Mr. C.V. Raman, Mr. Festweger, they would be concentrating more on the engine side. But nevertheless, we are cognizant of these challenges. So as Mr. Tyagi very aptly put it, the collective commitment of oil industry and automobile industry is by 2023, all the vehicles would be E10 engine compatible and E20 material compatible. And by 2025, they would be E20 both material as well as engine compatible. So we have done very elaborate studies as far as material compatibility is concerned. There are only 3 materials, 3 elastomer materials and 1 plastic material, which are actually registered premature fouling because of incompatibility. So I think automobile industry is concentrating on avoiding such materials in the fuel injector area, and they are finding out alternate materials to that. So I would like to end this my address by stating that with the attendant hydrogen buzz in the nation, ethanol and hydrogen need not be working at cross purposes as technology options. I think Brazil has already shown the way that ethanol can be synergized to the hydrogen economy by way of reforming ethanol either separately and producing hydrogen and using the hydrogen fuel cell vehicles, or onboard reforming, in situ reforming of ethanol through solid oxide fuel cells to fuel cell electric vehicles. So I think all the generated data indicate that ethanol can gel well even with the post-electric traction kind of aspirations that as a nation that we are going to we are nurturing. So ethanol economy is going to be here, and there is a definitiveness now. Honorable Prime Minister himself launched this roadmap. The two key industrial segments, the oil sector as well as automobile industry, they are working around the clock to make this mission a great success. We are ready to work hand in hand with automobile industry with the help of enabling organizations like ICAT and ARAI, and work with them to make the technologies amenable for E20 propulsion. Thank you very much.
Thank you, sir, for your kind words, and thank you for providing us a oil industry perspective. And we are grateful for your presence, and your presence has made us feel great. Thank you. And moving right along, it's my pleasure to introduce our next guest of honor, Dr. Reggie Mathai. Dr. Reggie Mathai is the Director of Automotive Research Association of India. And Dr. Mathai holds a Bachelor from Mechanical Engineering and a Master's from IIT Technology, Varanasi. He has obtained a management degree from Indian Institute of Management, Ahmedabad, and a Doctor of Philosophy on Alternative Fuels from IIT Delhi. Prior to joining ARAI, he has a 28-year-long association with Indian Oil since 1992. Thank you very much, sir, for your presence today. Over to you, sir.
Yeah, thank you, Ethan, for that introductory verse, and thank you, Mr. Tyagi, for this platform for deliberating on a contemporary topic that really has all of us focused towards achieving what the government initiatives of meeting the fuel self-sufficiency and also countries' economic some stability and a better role of the agriculture into the fuel part. I think my Dr. Ramkumar has given a very elaborate introduction on the availability of the fuel, but I just want to touch upon few areas along with it while going into what as a regulatory agency or what as a certifying body or what as a body that aligns with the automotive sector in providing solutions we look forward to. As Dr. Ramkumar was rightly mentioning, almost 2 decades back, around 2003, the introduction of fuel started. This blending of ethanol was thought of. It was a very scattered event, means almost just with 9 states and 4 union territories what commenced in something in 2003. And government made it into a little more broader picture in 2006 by 5% blending coming into place. Some studies were done in 2008 to 10 or 12, by which on 10% ethanol blending studies on material compatibility and its utilization was carried out. And by 2012, that is around 10 years after what was an initiation in 2003, the government introduced the mandatory 10% of ethanol. Now, another 10 years after this, from 2023, we are now looking at 20% of ethanol. So what has been the change from then to now is what has been a scattered orientation, as Dr. Ramkumar was mentioning, that 5% or 6% blending on an average was taking place, means some parts of the country having E10, some not having E10, had put a lot of constraints on the manufacturer. Especially, he was tuning his vehicle for something like E5, and that had some giveaways from their part. On the other hand, the OMCs, oil marketing companies, too were having some giveaways. In certain positions, they were giving high octane fuel like 95 octane, wherever the blending was taking place, and wherever it was not taking place, it was 91 octane. So it was not at all a situation where anybody was gaining out of it. So what this focused approach the government has brought in is, by bringing in E20, they have first tightened the requirement for E10. And as rightly mentioned, a lot of steps are being taken. And the first time government, whole agencies, I can say the food supply, the oil marketing company, the vehicle manufacturing ministry, Niti Aayog. So the first time they all focused together and this roadmap was laid down, where an assurance is almost given that the ethanol 20% will be consistently available from 2023 onwards at some majority of the places, and 25 onwards, it will be complete E20. Along with it, one of the other industries' requirement that 95 octane be made the base is under strong deliberation and consideration. So this is one area that is going to be a win-win situation for all of the fraternity stakeholders, where they believe that the necessary modifications in the vehicle can be taken care. Whatever loss due to the calorific value and all is going to take place can be compensated to a certain extent. But for the OEMs, there are challenges. I think my speakers after me will be addressing those as they speak on what are the challenges they are facing and how they will be addressing that. On the regulatory front, we have put into place almost all the requirements that makes this fuel to be used. As rightly mentioned, the fuel and safety standards, the AIS 171 for the ethanol vehicle safety has been put into place. The normal specifications through GSR are also being notified. There has been few amendments looking into its usage being a mono fuel or as a biofuel. That is under deliberation as of now, and it will also be taken into consideration. The other challenge that the regulator or as we face will be on the certifying part is the requirement of the reference fuel. So this is again being deliberated, trying to see that whether this reference fuel can be made available indigenously. The specifications have been deliberated with the SIAM and they have provided some broad guidelines. This is being also handed over to the oil companies through the Center for High Technology, where they are looking into study whether the reference fuel can be made on pilot scale. So once that also is met, I think we will have the necessary infrastructure readiness is already there, as Mr. Tyagi also mentioned in the beginning itself. The test agencies are ready with all the necessary requirements to carry out these evaluations. Along with it, there are some minor detailed studies to be carried out, which we are planning now with the OEMs and with the OMCs, oil marketing companies, trying to plug whatever issues are concerned, means are going to come out, so that we are completely assured of the fact that we are not facing any surprises sort of a thing when the fuel comes into play. Although there are been concerns, and this will be anyway taken care in the due course of time. So just to sum up, what I have been saying is, as the OMCs make ready the fuel and the availability, where the assurance is that all the major places, at least some of the oil pumps, will be made available with the E20 and E10 from 2023, and 2025 onwards it will be only E20. We on our part will be ready with the necessary regulatory aspects and the evaluation that is required. We also will be ensuring that the performances tuning or performance comparison, what are the giveaways and what can be the gaining out of it through some studies are put into place, so that everybody knows what we are entering into. The industry has its challenges, which they will like there are so many regulatory requirements coming into play. So they will be looking into all those aspects. How to address the CAFE norms? This is going to be another area that requires some deliberations, and I think that the necessary panels will take care of it in the due course of time with the automotive industry standard panels. We'll be looking into and taking care of that aspects also, how to think of CAFE and what is going to happen to it. We believe that the BS6 emission norms will not be having any implications of the E20 introduction. More or less, they will be able to meet the regulatory requirements. But the compliance part, in-service compliances, again, the vehicle service manufacturers will be touching upon them. With these words, I just want to thank you and wish this webinar all the best, and let the deliberations bring forward new points to be addressed to. Thank you.
Thank you. Thank you, sir. Thank you for your kind words and words of wisdom. And moving forward, I would like to introduce our next guest of honor, Mr. C.V. Raman. He is Chief Technical Officer of Maruti Suzuki India. And he has graduated from Delhi College of Engineering. Mr. C.V. Raman has been serving the automotive industry since 1982. He's now the CTO of MSIL and has been associated with Maruti Udyog and Maruti Suzuki for the past 36 years. It's an honor for us to have you, sir. May I now request Mr. C.V. Raman to kindly address us?
Thank you and good afternoon, everybody. Can you give me the sharing rights? I have a small presentation, just 2-3 slides. Is my slide visible?
Yes, sir.
Yes, sir.
Visible? Yeah. Good afternoon, Mr. Tyagi, Dr. Ramakumar, Dr. Mathai, Mr. Kasbekar, Pamela San. Thank you for this opportunity to participate in this webinar. It's a very important topic. Dr. Ramkumar and Director ICAT and Director ARI have already set the context and talked of all these the points, and it's very heartening to hear about the efforts being made in terms of making available the ethanol which is required and we have been working with the oil industry, the MOPNG, MORTH, DHI, Niti Aayog for the past couple of months, and the ethanol roadmap has been drawn for a lot of deliberations with the industry. Industry had certain viewpoints, but we all believe that ethanol is the way forward, and Maruti Suzuki, we believe that it is definitely help us towards decarbonizing the transport sector. So, we have been talking about ethanol being a means for reducing the carbon crude oil import and also support farmer incomes, as 83% of the fuel is met by imports. Of course, new paradigm is taking shape. We are the 4th largest greenhouse gas emissions historically, and of course on a per capita basis we are very low. And we believe that earth ethanol can kind of help in this journey of meeting the COP21 and thereafter the COP26 targets, so to speak. So as far as the stage 1 of the 2020 targets is concerned, I think India has already met and much ahead of schedule. Instead of 2020, we already met it in 2016. And the second phase of 30 to 35% reduction, we are also likely to achieve it much ahead of the schedule. And of course, current efforts are in line with the 1.5 degrees target for the global warming, and of course from we believe that this will help us in meeting in reducing the greenhouse gases, even though it may be pertinent to note here that cars and two-wheelers constitute roughly about 5%, 4.5–5% of the total contribution towards the greenhouse gases. And gasoline is of course about 12.5% of the total crude basket. But having said that, we are making the effort, and we will definitely believe that the ethanol usage of ethanol is going to help us going forward. Dr. Ramkumar has very clearly given the roadmap for ethanol, and there is a potential of utilization of ethanol in the next 10 years, and it's going to be we believe it is going to be at least 8 times of what it was in 2020. already from that 8.5% when we achieve this 20% going forward, and we're talking about flex fuel, definitely the consumption of ethanol is going to be much higher. The E20 can replace 14% of the gasoline fuel, and if vehicles are optimized, it can reach up to 18%. We have worked with the test agencies, with the government agencies, with the oil companies, and we have given a very clear roadmap as already discussed. 2023, we will make vehicles compatible for E20 up to and from 2022 onwards. Of course, E10 is all vehicles will be fully compliant. 2025, we will also ensure the tuning of the vehicles to E20, and all of this is going to help in uh, reduction of crude oil import, as well as reduce the greenhouse gas reduction potential. And we believe that there is going to be a reduction potential of about 16% if we move towards the E20 fuel. And so that's something which is, and if we are going to use E100, it is going to be carbon neutral in the way in which we are talking about. And so therefore, we believe that ethanol has a potential for a sustainable automobile fuel. Of course, all of this, as we have been deliberating, it requires careful implementation, and we need to maximize the utilization and the benefits. We need to ensure customer acceptance and drive the penetration of the biofuels. So portability and compatibility concerns are the key points. E20 fuel availability, Dr. Ramakumar has said very clearly it will be available. However, one concern point is the E10 fuel for existing customers, and this is something which we have been discussing, and we have been saying that it should be available. And also the E85 flex fuel vehicle for the flex fuel vehicle should be available in all over India, and that's because our vehicles are portable, and so therefore it should not be limited to a few states. Case in point, when we are talking about switchover of fuels or specifications, examples of USA and example of UK, very clear communication to the customer, very clear direction and warnings at the fuel stations for the ethanol percentages, and also education, and of course auto industry will be doing that. But of course, there is a larger role because when the customer goes to the gasoline pumps, one needs to ensure that he fills in the right kind of fuel for that. The other concern is, of course, the running cost concern. There is going to be higher fuel consumption with the E20, and of course, with E100 fuels, there is going to be 30 to 35% higher fuel consumption, and all of this is already known. And we have been, as a way forward, talking about around 95 across the fuels, both E10 and E20 is of course already notified, but we are engaging with the oil industry and requesting that E10 should be E10 also should be around 95, so that we can recover some of the fuel efficiency loss. Other key point, of course, is the pricing. This is one big issue going forward when we talk about flex fuel or E85. There has to be a price guarantee, otherwise to compensate for the fuel efficiency, and otherwise it is going to be very difficult, because the cost of the acquisition will go up for the flex fuel vehicles, and the running cost has to, in a way, because of the efficiency loss, that has to be taken care of. Industry has also been talking about some reduction in GST for the flex fuel vehicles to promote the carbon neutral fuels. And this is, I think, a continuous process of engagement, and which we believe that is important, but also these points should be, kept in mind when future policies are, are being promulgated, especially when you're looking at CAFE norms or future CAFE norms, and so on and so forth. So what is required very clearly is a very clear roadmap and visibility. One would like to see, which is we are seeing that there is some visibility which is there, but we should also recognize bioethanol as a carbon neutral fuel for GHG reduction. The carbon credits which is being talked about, that is something which should be also promulgated simultaneously, because the roadmap is of fuel, is about vehicles, and also about the cafe and the carbon credit. So all of that has to go hand in hand, and sufficient lead time should be given, and also should be promulgated and well in advance so that people can work towards it. Of course, sufficient lead time for E85 flex fuels is important. We have to, in the next 2 years, convert all our vehicles to E20, compatibility. It's a Herculean task. I can definitely tell you that. Even though it may seem that there are a couple of hoses which need to be changed, but there is a huge supply chain which is involved, and there is a lot of evaluation which is required to be done on every vehicle. It is cannot be done just on a generic basis. But of course, having said that, the auto industry will work towards that, and we definitely like to reaffirm our stand that we will be switching over to E20 compatibility by 2023, and also work towards the flex fuel vehicles. So this is something which we believe is important, and we'll continue to work on this and engage with the oil industry, test agencies, and with the government. And we definitely believe that this is a very important way forward for India. So thank you very much for the opportunity. I think it's a topic very important, which needs a lot of deliberation, and I'm sure there will be a lot of discussions around this. Thank you very much.
Thank you, sir. Thank you for giving us auto industry perspective, especially from the passenger vehicle segment, and giving us an overview. And for the wonderful address, we would like to thank you. And for the next address, I would like to invite Mr. Vikram Kasbekar. He is Executive Director and Chief Technical Officer, Hero MotoCorp. Mr. Kasbekar is responsible for plant operation catering to domestic, export, and after-sales market, and he encompasses product strategy, design and development, ensuring global standards in manufacturing and quality and delivery. He is an active member of CII Northern Region Council. Thank you very much, sir, for your presence. Over to you, sir, for your address.
Namaskar, and thank you very much, Mr. Tyagi, for this opportunity. A very good afternoon to all the esteemed panelists here and audiences, ladies and gentlemen. It's my pleasure to address this meeting. I must say that auto industry has been the backbone of manufacturing, not only direct but indirect employment as well. It has been providing. Let's take the case of Gurgaon itself, where all of us are present. The presence of Maruti, Hero, Honda, and many of these ancillary industries have contributed a lot for development of Gurgaon and contributed to the GDP of Gurgaon as well. So it speaks that what all auto industry can do for the economy of a country. I must say that this is a wonderful forum in which we have the oil industry veterans, the regulatory authorities, ARA and ICAT also coming together, and the industry. I think this is the era of collaboration, and it is very important that all the stakeholders collaborate very closely for the success of this project. My predecessors have explained very nicely about the roadmap for the ethanol conversion, and yes, as an industry, we do accept that challenge. What is important, I have seen in various interactions with the government of India, they feel that the industry is highly defensive and not very proactive. I think this impression has to change. Rather, this perception has to change, because in reality today, I think most of the OEMs worth their salt are having their own in-house R&D and are developing technologies for the future. Not just ethanol, but going forward, many other technologies of flex fuel that they will be able to adapt, including the EV. So we are in for a very exciting decade of change, which is coming through. At the same time, I must say that this collaboration has to be a win-win solution for all. Mr. Raman also mentioned about various aspects which are, I think, very critical to be noted and addressed. At the same time, I must say that we are actually dependent a lot on our customers, and we can't forego their interests. So with this change coming up, we need to see that how we address the older generation of vehicles, because there are millions of two-wheelers available, three-wheelers and four-wheelers also. Maybe four-wheelers a little more better off because they all have fuel injection. But the older generation vehicles do have the carbureted version. So we are working very actively with the regulatory authorities to look at what impact the E20 will have on the carbureted version. I'm sure it might have a little bit of fuel efficiency drop. Drivability is going to be important. But performance, I think, overall may not be impacted so much, including the regulations. I would only look at one thing maybe the government may need to consider: E10 as a base fuel for some time to come, based on the outcome of these results, and also give a little advantage to the older customers who are driving the BS3, BS4 vehicles for the loss of fuel efficiency, if any. But I think this tests and documentation and data would reveal a lot as we go forward. Yes, a lot of activity is going on improving the durability and compatibility of these vehicles and parts for the E20 fuel. And going forward, the industry is quite confident of ensuring that it comes through. Of course, the biggest challenge for the two-wheeler industry is more so on the OBD2 phase 1 and phase 2 compliance, along with E20. So that's a bigger animal. And that is where possibly we'll have to go through 3 sets of calibrations to come to the right solution. The roadmap has been very clearly been defined, and I hope the government and the industry does stick to that roadmap of making the fuel available. It's a very good situation, I must say, and industry will support wholeheartedly because it's doing multiple things together. A, we all believe on sustainability, and we owe it to our future generations to see that they have a better life going ahead. B, we look at overall benefit for the imports, for saving in forex. I think that's very vital for our economy. And number 3 is for our farmers. I think this is going to be a win-win situation for all the stakeholders concerned. Going forward, it's very important that in some of the ethanol surplus state, the North is talking about flex fuel. Mr. Raman did mention about 85%, and obviously 100% ethanol is not feasible. The flame cannot be detected, and then lower percentage comes as a cold start problem. So maybe we'll have to look at the optimal percentage of ethanol, and the loss in fuel efficiency obviously needs to be compensated by the costs. So it's important that the government has a very clear policy on the pricing of the ethanol as we go forward. The customer should also get the benefit of lower fuel efficiency on account of the flex fuel. If we look at the collaboration as we go forward, I think the regulatory authorities, the industry, and the MOPNG and the oil industry need to work in a very, very coordinated fashion for the future regulations. Industry is for it. India will come out as a winner, I'm sure, with the Atmanirbhar Bharat initiative, and also a, a, a very clear roadmap gives a clear direction for the industries to work in a very systematic fashion. Sometimes any ad hoc kind of a changes do create a lot of problems. Yes, it is important that we adopt to the best of the technology because we are competing globally, and unless and until we produce world-class vehicles in a sustainable fashion in the industry, we will also not survive. So we are upbeat, and we feel that yes, with a little give and take, we should be able to meet this challenge coming forward for the ethanol blending technology, whether it is ethane or flex fuel in some related vehicles. Yes, in some of the areas, it is important to understand from the oil industry as where the flex fuel would be available. So maybe a certain percentage of vehicles can be specifically made for those states because they require different materials, different hardware, and that would help the industry a lot. So I think, again, I repeat, this kind of a collaborative approach will take India forward. Thank you very much.
Thank you, sir. Thank you very much for your address and giving us a auto industry perspective on two-wheelers, especially. We are grateful to you. And now to conclude this inaugural session, may I request Srimati Pamela Tikku, Senior General Manager, ICAT, to propose the vote of thanks.
Thank you, Enoch. Am I audible? Am I audible, Enoch?
Yes, yes, ma'am, you are audible.
Yes, you are.
Thank you so much. Honorable guests of the inaugural session, Mr. C.V. Raman, CTO, Maruti Suzuki Limited, Dr. S.S.V. Ram Kumar, Director, IOC R&D, Mr. Vikram Kasbekar, ED and CTO, Hero Motor Corp, Dr. A.G. Mathai, Director, EREI, and Director, ICAT, Mr. Dinesh Tyagi, distinguished speakers, guests, ladies and gentlemen, and people from media also attending this webinar. As has been said by all the speakers today, this is the topic of interest for the currently for the country, because a lot is being talked about. So there are going to these policy decisions are going to lead to certain innovations and certain new technology developments. On behalf of ICAT, it's my privilege to propose a vote of thanks to all the members of this inaugural panel, which is being organized for 2 days, today and tomorrow. So we will, and this is being undertaken under the ICAT Technology Platform Initiative Aspire, which is an initiative by Department of Heavy Industry to create Atmanirbhar Bharat Abhiyan, which is a vision which has been proposed by our Honorable Prime Minister. As has been said, that on World Environment Day on 5th of June, Honorable Prime Minister released the report of expert committee on roadmap for ethanol blending in India 2020-2025. And it's a great honor that two of the authors of this report are part of this inaugural panel, both Dr. Ram Kumar and Dr. A.G. Mathai. And they have brought in their perspective, what is there in the report to the inaugural panel today, inaugural session today. This committee has suggested a roadmap of production and supply of ethanol blend, and has been also again affirmed by Dr. Ram Kumar today, what the plan of oil companies and oil marketing companies is to produce 10% and 20% ethanol, and how to go ahead with the flex fuel economy based availability. It's a great thing to understand, know that the oil companies have embarked into getting into biorefineries, and that I'm sure will help in achieving the objectives of the roadmap. I think earlier also when government had released the biofuel roadmap, that time the 10% ethanol blend was proposed, but it was not successful because probably the whole concept was based on the disruption, and hence it was not profitable for the oil refineries to blend Honorable Prime Minister is realized through these efforts. I, on behalf of ICAT and on own behalf, would like to extend a very hearty vote of thanks to all the panel members for their presence and sharing their valuable time in today with us and sharing their experiences and expectations both. It is very important to also know the expectation of the all stakeholders. And I will also be thanking all the delegates. We have today 197 people who have registered at this moment. So I am expecting this registration will grow more during the course of today and tomorrow. We have brought in a very good mix of experiences, both national and international speakers, and their presence and their experience sharing will bring lot of value to the participants in the webinar, and we can have key takeaways from these experiences that they will be shared. So I'm sure that the participation of all the participants and the speakers will lead to better adaptation and implementation of the roadmap objectives. This event was organized on a very short notice of time, and Ministry wanted us to do something on ethanol economy. And under the leadership of Mr. Tyagi, Director ICAT, and our team put together this this webinar, and a very beautiful composition of speakers, not only from India but also from overseas. And we, although Mr. Joint Secretary Refineries wanted to participate in the inaugural panel, but due to parliamentary session, he regretted at the last moment. So it would have been good if we would have had also a government participation today. But nevertheless, we have a perspective from all the stakeholders here. I would like to thank a team, my team, who has put in a great effort in putting up this webinar: Ankit, Enoch, Vikas, Sadan, Sitaram, and his team members, along with Sogata and Abhijit from Aspire. We also have a convention center which was constructed 2 years back, where we had a New Gen seminar. Unfortunately, due to COVID, we could not have physical events there. But we have a team, which is our ICAT Convention Center team, has put up this webinar together, and it's an excellent way of continuing of interacting with all stakeholders in industry. So my thanks goes to Anurag Jain, Vibhu, Krishna Govind for organizing this seminar webinar seamlessly. I once again thank you all for your participation and your valuable inputs. I'm sure today and tomorrow's deliberations will help everybody who are currently connected through the webinar. Thank you so much, and I hope you all have great and safe days ahead. Thank you.
Thank you, ma'am. Ladies and gentlemen, with this, we conclude the inaugural session of this webinar. I once again thank all the dignitaries for their valuable time and all the delegates for your kind attention. For the positivity of the time, we would proceed to the session on technological challenges, and welcome to the session on technological challenges of ethanol. There is a famous saying, challenges is what makes life interesting. Overcoming them is what makes them meaningful. In this session, we have experts with us who will be presenting their experiences with us. And we have Professor Avinash K. Agrawal from IIT Kanpur. And we have Dr. S.S. Tipse, Deputy Director, Powertrain, ARAI. And Dr. Devendra Singh, Principal Scientist, IIP. And Dr. Devendra Deshmukh, Assistant Professor, IIT Indore. Thank you very much. Thank you all for your time and presence with us. Since we have moved little higher on the time side, and we have approximately 1 hour to finish this session, I would request all the presenters to please restrict your presentations to maximum 15 minutes. And it would be we'll be very grateful to you. And for the first presentation, may I call upon Professor Avinash K. Agarwal for his presentation. Dr. Avinash Kumar Agarwal is PhD in Energy from IIT Delhi. He is serving as SBI Endowed Chair Professor currently. At IIT Kanpur, Professor Agarwal worked in the areas of IC engines, combustion, conventional fuels, alternative fuels, fueled engine development, and several advanced IC engine subjects. Currently, Professor Agarwal is involved in the development of methanol and DME fuel vehicles for automotive sector. For today's presentation, his topic is ethanol economy in India and the technological challenges. Over to you, sir. Over to Professor Agarwal.
Thank you, sir. Good afternoon. Thank you very much for giving me this opportunity. I would like to specifically thank Mr. Tyagi and Ms. Pamela Tikku for the kind gesture of inviting me to share some of my thoughts about it. I hope you are able to see my screen.
We can see your screen and your
audible.
Yes.
Okay. So if you look at the biofuels, there are several generations, as it was talked in the previous session as well, that there is a first generation biofuel, which would include, bioethanol, biogas, biodiesel, etc. And then there is a second generation biofuels, which is basically biofuel generation from cellulosic biomass, biomethanol, biohydrogen, etc. And then there is a third generation biofuel, which is either an algal biofuel, or basically you capture the carbon dioxide from the atmosphere, and then using the biotechnology fix it to produce biodiesel. Or the fourth generation is basically the synthetic biofuel, and these are quite relevant for India because they lower the emissions, they increase the employability, they increase the rural development, national development. We don't have to import, so energy security is far better, energy independence, and also they are environmentally. We all know this. Now to achieve this, what is done is there are 4 missions that are currently in different stages of implementation. And one of them is Ethanol Economy, about which I'm going to talk about. But then there is a methanol mission and there is a hydrogen mission also. And then we all know that battery electric vehicles are being implemented countrywide on a big scale. So right now we are talking about ethanol and also battery. And in times to come, finally, we'll be also talking about methanol and hydrogen. And all these are equally important. Reason being that there is no single solution to the transport energy requirement and other kind of energy requirement. And we need a host of solutions, and all these fuels are solutions. So let's first look at what is ethanol economy. So basically, what we are talking is end-to-end conversion of the fuel. So we can actually use a lot of different varieties of biomass, such as sugarcane, molasses, corn, cassava, beetroot, rotten food grains, and then you process it via this 3 or 4 stage processing methodology, and then you generate ethanol, and this ethanol can be used for a variety of applications, including transport. We are also talking about ethanol being used for other commercial applications. So this, in a way, is in a glimpse, we are talking about ethanol economy. Now let's look at the international status. So ethanol blending program, as we call it, it is being adopted worldwide. In Europe, currently it is at E5 level, and in the future we are talking about taking it to E10. In the US, it is around E11. In the China, it is around E10, and they are also going to increase. In Brazil, it is around E27 right now, and they target to take it to E40. And as we know, in India, we are currently at about 5. So our blending program started around 2014-15, and then because of the supply limitations and fluctuating prices of the sugar, this program has actually seen its ups and downs, and then it went up to 3.5, again 2.1, and then finally In 2019-20, we have roughly about 5.12% ethanol in the blending in the petrol, and then we would like to take it to 20% by volume ethanol by 2024. And I think a nice report was discussed by Niti Aayog. It was discussed in the previous session. So if you look at the production as a nation, we are producing mostly 1G ethanol, first generation ethanol, and then we are moving in the direction of 2G and also in 3G. So this just shows, how many crore liters of ethanol has been produced and how this growth has taken place and what are these sources. So you can see that mostly, the ethanol that is produced in yellow color is C heavy molasses, and we have also started using B heavy molasses. And the sugar cane juice is very small and its production has started really recently. And then, manure, etc. is also being used, and FCI food, FCI rice, which gets gotten, that also contribute. But we have a long way to go as far as production is concerned in next 4 to 5 years. So we will be using a lot of biofuel stuff. And of course, the majority of the ethanol that is being produced in the country is fermented ethanol. And worldwide, this conventional method is being used for fermenting sugar cane, maize, beet, fruit, corn, etc. And then, solid waste could be used for fermentation, and this will reduce the waste problem. It will convert the waste into wealth. And there's a single step process where you take carbohydrates and you convert them into ethanol, plus you produce some carbon dioxide. The challenge here is that you produce an aqueous solution of 14%, and when we want to put it in the engine, we need 100% ethanol. So removing water is kind of challenging from ethanol, and that really substantially increases the cost as well. Now, if you look at the bioethanol, you are using basically the waste biomass and using bacteria to produce ethanol. It's a relatively slower process, and generally E. coli bacteria is used. But then, you can use a lot of residues such as forestry residues, rice hulls, which otherwise are going to go waste. And this really takes care of the waste disposal problem. But the process is really slow, and its commercial production of ethanol using this process is really nascent stage, which needs to be improved. In US, BC International Corporation is working to make it commercially viable. So they are taking biomass, and then this hemicellulose hydrolysis is done. Then separation is done between xylose and cellulose. This cellulose is again, hydrolyzed. We convert the glucose to ethanol and xylose to ethanol, then do ethanol separation and lignin residue separation. So these are the steps for producing actually the ethanol to waste. Now let's come to the cost, because cost is extremely important for the success of any fuel. So in the US, the cost currently is 61.3 cents per liter. Brazil, it is about 60.6 US cent per liter. Thailand is about 0.684. And here you will see that from different sources in India, the cost is relatively higher than these countries, slightly higher than this country. In terms of rupees also, this is quite high when you compare 60-65% calorific value compared to petrol and diesel. So higher ethanol price is a major bottleneck for this to become popular with the masses. So government has to actually make some policy to cap these prices, and they should say that we will cap the ethanol price at say 60% the cost of diesel. Only then this will make sense for the ethanol blending on a commercial basis, and only then it will be very attractive for the population. Now come to the technological challenges of having E20 in the engine. So there are many challenges which include effect on the plastic parts, O-rings, because the swelling action and that produces the life. Then there is a challenge of emissions. With the ethanol, there is a problem of aldehyde emissions. Then there is a problem with the metal parts. Some of them get attacked by corrosion because of ethanol, and then you have cold starting issues. And then if you are using EFI systems, which most of the high CC motorcycles in India and cars are using, then you have drop in the fuel efficiency, and you need to recalibrate the fuel injection system. Even in the fuel distribution system, you have to make some modification in the storage tanks and in the fuel outlet, because ethanol, it integrates the plastic components and metal and rubber components. It's causes swelling and softening because it has solvent-like nature, and it also affects the degradation of the metals because of its acidic and galvanic nature. And it is slightly corrosive and hygroscopic, so it attracts the moisture from the environment, and therefore it causes the water contamination. This really remains a major problem with the ethanol use, particularly in the vehicles. And metal corrosion risk increases significantly with time. The other issue with this ethanol use is methanol compatibility, particularly with the FIE parts. So, the vehicles which are using either port fuel injection system or injectors or even carburetors, some of the materials need to be changed. So you need to remove the PVC and rubber parts with the HDP, nylon, or Teflon, and this is going to increase the cost of the FI slightly. So this, if it is done right at the manufacturing stage, then this cost increase will be rather limited. Then, as mentioned earlier by previous speakers also, that there is a cold start problem. And the cold start problem is because ethanol is a single component fuel having a boiling point of 65 degrees. So if the temperature is below 11 degree, then mixture is not rich enough to support combustion. So in temperatures below 11 degree, E100 is definitely not going to work. But we are only targeting E20, so it is not really a major problem. Slight inlet air heating or fuel blending are the possibles. Now, coming to the unregulated emissions, this is a problem. This curve shows different unregulated gases which are coming out of the vehicles, and here, sky color is ethanol 0, which is gasoline basically, and this is E85. So, and these are all carbonyl compound emissions. So you can clearly see that formaldehyde and acetaldehyde emissions are high if you are going for E85. But with E10, E15, E20, it's not really such a major problem. And even if it is there, you can really tune the catalyst of your vehicle and control the emissions from the vehicle, engine out emissions. Again, if you're using a EFI system or PFI system, then for methanol adoption, you have to do entire recalibration of the ECU. And for that, this is the ECU map, and so you have to look at basically the cold starting conditions, low speed, low load conditions to cruising speed. So different zones of the map have to be recalibrated. And say, for example, for the starting, you can make the vehicle run a little richer. So you can see the phi values less than 1. And in the cruising, you can have slightly leaner mixture. In the main vehicle operating region also, you can make it slightly lean. So this calibration can be easily done, and this will be able to remove the problems of drivability, remove the problems of efficiency. It's not really a major issue as such, which cannot be tackled. Similarly, the biggest challenge with the ethanol is going to be food versus fuel debate. So we have to steer clear of it. We have to use the feedstock which is not food, but the other challenge that is there is the requirement of water. So if we blend water, ethanol at 5%, this will be our water requirement. If we blend at 20%, this will be our water requirement. Water quantities are given here. So where this water is going to come from, that is a big challenge. So this is the requirement in the USA in the corn. This is the Brazil water requirement. This is for the India. And so India, we will be using a lot of surface and groundwater. So this is going to be a real big issue going forward if we don't take care of it right in the beginning in our planning stage. Then, there is a continuous rise of ethanol prices, which will increase the petrol price, and this will make the proposition unattractive unless and until we cap the prices of the ethanol with respect to gasoline. So there are challenges, but there are solutions, and the way to tackle these challenges is to collaborate.
Sorry, sir, to interrupt. I would request you to please conclude because we have short of time.
Yeah, I'm at the last slide.
Thank you, sir.
Actually, last 2 slides. In 2 minutes, I'm still at 13 minutes. So this is not related to ethanol, but this just shows the projections of the vehicles that are to be sold. And here you can see this is the vehicles annual sale in 2030. This is the annual sale of the EVs in 2030. So the point that I want to show is that even by 2030, the IC engine vehicles will grow by about 70% in next 10 years. So even in spite of 30% growth or market capture by EV, IC engine vehicle continue to have a 70% growth. So the automotive industry should invest in R&D in the engines. And so we have a lot of facilities to actually collaborate and help auto sector. And we already have a lot of collaboration. And with this, I conclude. Thank you very much.
Thank you, sir. Thank you, sir, for the interesting presentation. And if our viewers have any questions, I would request you all to kindly post it in the questions. There is a tab on your right. You can use the questions tab to post your questions. And I would also like to take this opportunity to invite Mr. Dinesh Kumar. He is the Vice President of SUD Chemi. He has joined us along with our esteemed panelists. In this session, we have Mr. Dinesh Kumar, who is Vice President of SUD Chemi. For the next presentation, may I invite Dr. S.S. Tipse to deliver his presentation. Dr. Tipse has done his master's in thermal sciences from Batley University and his PhD from New Jersey Institute of Technology in the field of alternative fuels combustion. And he has research experience of over 20 years in the development of alternate fuels, engines and vehicles. And he has been working with ARAI since 2004. He is currently handling the development of CNG, LPG, HCNG engines, and he is heading the powertrain engineering laboratory at ARAI. And he has completed successfully various projects for major OEMs. And he serves as a member of the expert committee on alternative fuels of Department of Science and Technology, DST, and MNRE. He represents India on ISO Technical Committee 22 and ISO Technical Committee 197 on gaseous fuels standards. He's also the chairman of BIS TED 26 National Standards Committee on Gaseous Fuels. He has published 14 books and has 6 patents to his credit. We are thankful to you, sir, for your presence today with us. And over to you, sir, for your presentation.
Is my screen visible?
Yes, sir. Yes.
Yeah. Thank you. So first of all, thank ICAT, particularly Mr. Tyagi and also Pamela ma'am for having me here to discuss regarding the ethanol regulatory and technical perspective. So I think my predecessor, Dr. Agarwal, has given an excellent overview of the technological aspects. I'll just focus on the regulatory part and just walk you through different rules and regulations because I have been closely associated with this activity. So as of now, clearly it is known that need for ethanol is very well justified because we have many compulsions in terms of having the vision of Atmanirbhar Bharat. We have signed the Paris Treaty. We have to ensure temperature rise has to be controlled. Local pollution is also playing a major role. Then the economy has to be boosted in terms of self-reliant in terms of fuels. And again, CO2 concerns are always there. So mitigation of CO2 is very important. If we see our roadmap, we started with petrol, diesel, slowly went on to CNG, and then we also brought in the biofuels. Somehow the first generation biofuels did not take up to a bigger extent. But then slowly we are moving towards now ethanol and other fuels. And eventually we might land up with synthetic fuels and finally hydrogen as the cleanest fuel. So all this is being documented for India. And a lot of work is being done on all these different fuels, which is a matter of satisfaction. There are, as far as rules and regulation is concerned, for any technology to succeed, there have to be proper certification and approval. And for these different rules are there. I have bucketed them in 4 parts. In terms of the fuel sale, the oil marketing companies are the principal parties, and petroleum rules are allowing the fuel sale to vehicles. As far as the vehicle type approval, all the type approval agencies like ARAI, ICAT are there, who are type approving the vehicle and doing the COP. As far as the gas stations is concerned, the fuel stations, that is under OISD and PESO. And again, the cylinder and valves are under the explosives department as per the different gas cylinder rules which get amended from time to time. In the interim, Government of India had released many notifications notifying several alternative fuel vehicles and the fuels for different alternate fuel vehicles, which are just briefly listed here. Some of them is very clear. Even surprising part is that the synthetic fuels have also been now notified, like DME is notified for automotive use, apart from different blends of ethanol, methanol, then LNG and many other fuels, including hydrogen CNG. So all these notifications are available in public domain. ARI played a major role in, of course, the notification process. Coming to the biofuel generations, my earlier speaker already talked about it. So we have various generation of biofuels based on the feedstock, based on the source, which is giving different benefits. Now, definitely why we are more focused on biofuels is because of the benefits to the agriculture, ecology, and different aspects in terms of employment generation, innovation, and again, energy security. So in terms of the biofuel policy, the government has released this. Now, recently, it has been amended to 2025. The Honorable Prime Minister launched this program, and it is expected that E10 will be achieved somewhere in 22, and 23 we will be starting E20, and later on by 25 we will be fully using E20 as a fuel. And there are some concerns from the auto industry in terms of stopping the protection grade of E10 for the older vehicles. But again, discussions are going on how about going for that one. This roadmap, which has been recently unveiled by the Prime Minister, which tells about how the pan-India rollout is going to be, how the E10, E20, and again, they have encouraged the production of ethanol not only from sugarcane, but also from waste grains, excess sugar, and all this, which will contribute to the ethanol blending. But if we see the earlier implementation, we have seen that even early on in the program, not even 3% blending was being done. But now with the focused efforts at this present moment, we are around 8%. And we expect that after this, we will soon reach 10% and gradually go to 20%. So there is a difference. Our pace has increased and India is now focused on the ethanol blending. As far as the notification and standards is concerned, we have already released from the ministry all the standards pertaining to ethanol 85, that is flex fuel vehicle, blended vehicle, even the E100 pure ethanol vehicles. Then for the blends, recently E20 was notified. Even E12, E15 blends are also notified. Then the fuel safety standards have been put in place. I am happy to say that I was one of the primary authors of AIS 171, which was the safety standard kind of its unique document released in the country. Also part of the various BIS committees which form the IS 17021 and 17586. Along with that, there are further standards like 16634 for E85 and 16629 for E95. So these all standards have been notified by BIS. The rules and notifications have been given by ARI and all the test agencies. And with this, all the test agencies can certify any vehicle running on ethanol as of this moment. Then the safety standard, which I talked about, which was a document which was prepared, including all the safety requirements, material compatibility, health safety, fire safety, everything is there. It's quite exhaustive standard, very well appreciated by the industry, and this standard has already been implemented. Worldwide, if we see that flex fuel also is being used, and around in US and Brazil, they have the maximum experience with that kind of vehicles. Brazil goes from 27% up to 100%. US goes from 50 to 85%. Various states, various countries have different blending formulations. We in India have allowed E20, and now we are looking for E85. The flex fuel policy will come out very shortly. I will skip about the advantages because much has been talked about advantages and limitations of ethanol. I just want to focus that the limitations can be overcome by proper design. We have to take care of especially the material compatibility parts, and some modifications are very much required. My earlier previous speaker also showed some of the modifications. So all of this has to be done to make engine ready for the higher ethanol blends. Now, as far as E20, we did a lot of work on E20. ARI along with IOC and IIP, we carried out exhaustive testing on E20 fuel. where we did component rating, evaporative emission, exhaust emissions, field trials, lab experiments, and we made up a report and submitted to the government. Now we are going to phase 2. We are going to go with much more metrics of vehicles. This was done for the BS3 and BS4 vehicles. Now we are shortly embarking on BS6 study, and all the different aspects were covered in our study. So this was a joint project of its kind, and we observed that in terms of the mileage and all, there was some drop, but in other performance it was very good. NOx was more on a similar condition as far as emissions were concerned, but the fuel economy had suffered and deteriorated, and the non-regulated emissions were also very much there. Also, the rubber parts used to fail in that, particularly polyamide 66 and certain rubbers failed, which was a cause of concern. And similar results were obtained in M15 also. So these will have to be changed as we go along. So these are some more screenshots of that in terms of tensile strength, impact strength gets suffered when these fuels are exposed to higher ethanol blends. Talking about flex fuel technology, E85 is one of the promising technologies where you have different kinds of, the engine can be tuned to run on various blends. So you can vary the blend as per load and speed, and that gives you flexibility of running the vehicle. Suppose availability concerns are also there. Sometimes only 40% or 50% ethanol is available. In that case also vehicle can run, and the ECU is intelligent enough to sense the ethanol content in the tank and then adapt to the tuning. So it will self-adapt in terms of selecting the proper curves for ignition and other things. So that flexibility is what makes it a flex fuel system. And you need certain walls and certain modifications in the system to make it more smart. So these kind of vehicles have been developed internationally, like many other organizations like Volvo, then other in terms of Scania, have already developed E85 engines. Ford, GM, Chrysler in USA already have developed E85 engines. In India, so far, nobody has introduced this, but there is a lot of push from the government to introduce this technology into India, particularly for the regions where ethanol is available in surplus. Only point of concern is the fuel efficiency drop. When we go to higher blends like E85 or E100, there is a fuel efficiency drop of around 25 to 30%, which is a major concern. So like some of my previous speakers said about fuel pricing is very critical, because we have to make sure that the drop in fuel efficiency is compensated by the lower price, so that customers should not feel cheated out in terms of giving a fuel with a lower calorific value. Rather, he can be compensated with giving a lower price, and then he'll be very happy to accept this kind of fuel. And that is one of the big takeaways of this particular thing. Then again, E100, actually it's not E100, it's 93% ethanol with 7% additive. So that can also be used as an ethanol fuel. One bike has already been developed by one of our OEMs, and it was displayed to the minister and in some of the show organization. And that is not commercially introduced yet, but in the future we might have this kind of vehicle models, ethanol bikes running on the Indian roads very shortly. Then there are certain modifications in this case also, so I won't go into very much details in interest of time. But the cold starting and then the RON, we were mentioning about the RON. So RON 95 is definitely preferred, and higher RON is better as far as the combustion is concerned. As far as use in diesel engines is concerned, there is this Scania, they developed technology, ED95, where you use ethanol with additive and use it in compression ignition vehicles. So this kind of technology has already been developed. Some ethanol vehicles like that have been already imported in India, best suited for trucks, LCVs and buses. And this has an engine with a very high efficiency. You get an engine with almost 28 compression ratio, with a high compression ratio with additives. You can use it into the engine and run it. It is permitted as per rules, Indian rules right now. And this is the composition of the additive, and including denaturants, ignition improver, lubricant, corrosion inhibitor, all these things are part of it. So these kind of buses are running in Nagpur. Already pilot buses are running. ARI had also approved some of these buses. Then again, in ARI, we also did one experiment of blending diesel with ethanol. And this was a very unique experiment where we used this MSRTC bus for doing this experiment. So primary, this kind of activity was done in Karnataka, where KSRTC ran some buses on that, and they found very good results. So similar work we did in here in Maharashtra. So with funding from CHT, we were able to run some of the buses with diesel ethanol. We got very good results as far as these studies are concerned. Coming to the last slide, important thing is whenever we talk about ethanol or any such fuel for that matter, R&D I feel is the key to really work on that. So we need to understand the fuel thoroughly. We need to do fuel characterization, material compatibility studies. We need to do emission studies, then engine performance trials, road trials. And we really need to do this in the Indian conditions. People have the misconception that any technology can be imported from abroad and used directly. That's not the case, because our conditions in terms of climate, road conditions, then all driver habits, traffic conditions are totally different. And India is a very diverse country with diverse environments. And here, any technology will not directly be used, which has successfully been used outside. So you need localization, R&D, a lot of trials, redevelopment, a lot of things are required to really make any technology successful. So that is where I think institutes like ARAI or ICAT can play a major role in terms of localization. And that's a summary for this. Definitely, ethanol is a high priority area for Government of India. Definitely, technology is available for use in diesel and petrol engines. Standards, regulations already have been published. And there's a kind of a request that we should have the protection grade E10 continue along with E20 so that the older vehicles can be taken care of. And ARA is again committed to work with everybody for development and certification of vehicles. So with this, I will stop here. Thank you very much for a patient listening. And with this, I hand it over back to the organizers. Thank you very much.
Thank you, sir. Thank you for the wonderful presentation and giving us a technological overview and also giving a brief of the regulatory standards. Thank you very much for your time. For the next presentation, may I invite Dr. Devendra Singh to share his presentation with us. Dr. Devendra Singh is a principal scientist at the CSIR Institute, Indian Institute of Petroleum, Dehradun. He is B Mechanical from Nagpur University and MS Mechanical Engineering, University of Huddersfield, UK. And he received a PhD in Energy Studies from IIT Delhi. His research interests include IC engine emissions, performance evaluation of engine lubricants, fuels alternative fuels through field trials, alternative fuels for CI engines, steady state and transient emission analysis, suit analysis, and design of experiments. We are honored by your presence with us today, sir. Over to you for your presentation. Kindly unmute yourself.
Are my slides visible to you?
Yeah, it's visible.
Okay. So very good evening to you. And it's an honor that this timely organization of this E20 program has been initiated by ICAT. So I must congratulate ICAT for such a timely conference or webinar, I can say, in which we can share our experiences with E20 fuel. So in this presentation, I'll be just covering what IAP has done with regard to E20 fuel when it is utilized in our IC engines, and how we are using this fuels with respect to your emission characteristics, deposit characteristics, and material compatibilities. So I'll slightly touch things about your ethanol economy, followed by the presentation, which covers our field trials, which we have conducted on E20. So what are the main rationales behind this E20? We all know that energy security is one aspect, stringent emission norms is another aspect, and environmental concerns. So whatever things we are doing, so our energy security has to be in such a way that we should choose some alternatives which will address this issue. So as we know that energy security, India imports around 80% of crude oil for its energy requirement, and it's a continuously increasing trend. If you can see here, it's a continuously increasing trend. So if we can able to reduce 10% of it with the help of biofuels, then it would be a good huge revenue saving for our India. Next is emission control. So stringent emission norms are there. From April 1, 2020, we have BS6 emissions in India, and we have to be whatever alternative fuels we choose, it should address this emission norms also. And most important thing is the environmental concerns. So whatever alternative fuels, so what are the sources, what are the feedstock, should be renewable, should contain carbon emission and GHGs and biodegradabilities. So all those things needs to be taken care. And what is the alternative? So one alternative is ethanol. So let us see the projections of the ethanol. So I have taken this thing from the latest expert committee report only, in which the ethanol demand projections were shown. So we have by 2025, we should at least have 1016 crore liters of ethanol. And as we all know that in the automobile sector in India, we have a fairly major share of gasoline vehicles. 83% of the gasoline vehicles share. So it really makes sense to introduce ethanol in our automotive sector, so that it will address this issue of 83% of vehicles which are running in India on gasoline. So with this ethanol, now the big question comes, ethanol economy. So what is ethanol economy, first of all? Ethanol economy, it deals with scarcity. We all know that any economics means scarcity. So use of scarce resources. So what are the use of scarce resources we have? Molasses. India predominantly producing ethanol from the molasses or grain-based distilleries currently. And another alternative could be biomass. So we have to use our all scarce resources and allocate them to produce some meaningful goods. So the meaningful goods would be ethanol with the different production types. So we can produce this ethanol directly from sugar syrup, from B-heavy molasses, from C-heavy molasses. And one statistic shows that if we consider a sugar syrup directly converted to ethanol, so 1 ton of sugarcane gives you around approximately 115 kg of sugar if we are taking molasses route, C molasses route, sorry. So, and no ethanol. And if we take a case of total sugar syrup converted into your ethanol, then it produces around 84 liters of ethanol, but no sugar. So a better option would be to produce the ethanol from B-heavy molasses. That may yield you a fair amount of ethanol and some amount of sugar also. So now that next is consumption. When we produce, so how we consume that. So consumption is for, definitely we are talking about, the context is blending with gasoline, and it has other uses, but we'll focus on gasoline blending consumption. And ultimately it's the welfare of the society. So economy always tells about managing the scarcity with some ultimate aim of welfare of the society. So having said that, ethanol economy. So this whole ethanol economy or ethanol blending program initiated in India in year 2003, when it was initially started in 2003. And as per the latest national policy on biofuel, it says that by year 2030, we should use E20. But the latest report on roadmap for ethanol blending, we have advanced this time period from 2030 to 2025. So now I'll be discussing what exactly we have done in case of E20. So we have conducted a small study in 2014 and 15, and where we have chosen a vehicle of some old vehicles and some new vehicles, and it is a mix of, you can say gasoline and E20, and total 9 vehicles were chosen, of which 3 are the new vehicles and 6 are the old vehicles. And we have made 2 makes of the engines with the objective of fuel economy and mass emissions at the start of the field trials and after every 5,000. So the important thing is, for the old vehicles, the total field trials has to be conducted for 15,000 kilometers. And for the new vehicles, it is set at 20,000 kilometers. So what we did is, we use the E20 fuel, which is blended here, and we added some additives which were supplied by IOC R&D, and then material compatibility studies was also conducted. That was done by ARI. My previous speaker has already covered that aspect of it. And finally, the deposit rating characteristics of the engine parts, seeing what fuel properties affect your deposit ratings. So these things are covered at IIT. So now these are the details of the vehicle. We have 9 vehicles, and these are the details. First vehicle, 5th and 9th are gasoline, and rest of the vehicles are running on E20. So these are the field trials which we have conducted, and the route which we have chosen for this field trial, we tried our route in such a way that it should have a fair amount of city driving, a fair amount of your highway driving, as well as the rural driving. So we have this route on which the vehicles were run daily for about 90 kilometers per day for half day, and then another 90 kilometers. So there are approximately 180 kilometers per day we run the vehicle, and we maintain all the log sheets daily. So these are the details of the matrix which we are having. So these are the details matrix which we are having, and the test route details. Now the test results. So as CO, if you see the CO emissions, when we use a E20 fuel in our vehicles, so we are getting a lower amount of CO, relatively low amount of CO as compared to a gasoline vehicle, and it is very much related to the oxygen content of the ethanol, which is there, and we can see the reduction in CO. And also there is a reduction in hydrocarbon emissions as well. Again, we can say that the emissions are due to, the presence of oxygen and the other aspects which are important. And we are getting CO and SC lower than the gasoline fuel vehicles. NOx is a slightly different trend which we got. And in literature also, if you see, the NOx trend says that it is, in some cases, it says it increases your NOx emissions, E20, and some cases it says E20 decreases the NOx emission. So we ran this vehicle and we measured this emissions on IDC cycle. And since this IDC cycles are there, on this cycle we have run a NOx of the vehicle, and this NOx trend, we got a slightly higher trend across all nine vehicles. And one reason could be of this is, you can say, obviously the fuel bound oxygen, it is there, and you can say the laminar flame speed of the ethanol is 24% higher or faster than your gasoline. So higher is the flame speed, so higher would be the temperature, and higher would be the NOx. And why some people got lower emissions and some people got higher emissions? So it is a effect of the combined parameters: the fuel bound oxygen first, the high latent heat of vaporization of the fuel, and the third and most important is laminar flame speed of the E20 fuel. So when we see IDC cycle, so it is normally run on a mild cases, but at the last cycle it is at very high RPM. So we have higher NOx emissions with the E20 fuel. Fuel economy, as expected, we are getting some deterioration in fuel economy across all the vehicle, and it is seen that the fuel economy it is again correlated with the calorific value of the ethanol, which is quite low as compared to your gasoline. Now the important part is the assessment of the engine parts. So what we did is, on the old vehicles which we have stripped the engine and we conducted a deposit rating of the various engine parts for its various varnish, carbon and lacquer deposits or sludge deposits. And then we compare those deposits with the ethanol. So what we are saying is, as the gum content is the very important property of a fuel. When the gum content of the fuel or the E20 is there, so we have to take care of the intake valve deposits and other deposits which are there. So combustion chamber deposits is very critical in case of your gasoline engine, because as you have CCD, higher CCD, your combustion chamber deposits, that may lead you octane number requirement increase because of the reduction in your clearance volume, and hence it increases the compression ratio. That's why the ethanol plays a vital role in the in-use vehicle which are running, and they have a sufficient buildup of the carbon deposits. And again, the varnish deposits, we have done a detailed study of this piston, each zone, top groove, top land, crown land, top, and all those things we have seen and compared this thing. Not much appreciable differences we found, and it is almost comparable to the things. So like in intake valve, you see this is the deposits which are there. So these are comparable to those things. And so this is what we have done in this. So to summarize this thing, all vehicles successfully completed the field trials in terms of accumulating their stipulated kilometers in real driving conditions. Mass emissions of the vehicles, E20 showed relatively lower CO and SC emissions than gasoline, and NOx emissions are marginally higher for E20 vehicles when these vehicles run on IDC cycle. Fuel consumption, again, it is lower than you can say fuel consumption is relatively higher in terms of E20 because of its lower heating value, and the rating results are almost comparable to the gasoline vehicle. So now the next part is, we did the studies on carbureted engines and all these things. So now, if we can use this, what is the way forward, the future research? The study, if we studying the effect of E20 fuel on GDI and PFI engines compliant to BS6 with respect to regulated, unregulated emissions, performance, and deposit characterization. This will help us to be ready for our 2025 target, which is there in the. I would acknowledge the participating agencies in this project, which we have conducted in 2014 and 15, and the whole project is supported by Department of Heavy Industry, Delhi. Thank you very much, and this is our goal, to clean our environment and preserve for our next generation. Thank you.
Thank you very much, sir. Thank you for sharing the study which you did and the field trials data. Thank you for sharing it with us and the attendees. And we are grateful for your presentation. Now for the next presentation, may I request Dr. Devendra Deshmukh to share his presentation. Dr. Deshmukh, he is Assistant Professor, Mechanical Engineering, and he received his PhD degree in Mechanical Engineering from IISc Bangalore in 2012. He carried out his doctoral research in the area of biofuel spray characterization at high pressures. He has previously worked as a research engineer in GM-TCI Bangalore and TVS Motor Company. His current research interests are in the areas of biofuels, spray and combustion diagnostics, and modeling of IC engine processes. Thank you very much, sir, for your presence today. Over to you for the presentation.
Thank you very much. Are my slides visible?
Yes, sir. Yes, sir.
Yeah. Thank you very much. Thank you for the brief introduction, and I would like to thank ICAT and the organizing committee for giving me a chance to provide my research in the area of engine combustion, specifically related with ethanol and its blends. So the topic of my discussion today is engine combustion development with ethanol and blends. Thanks to the predecessors, we have very nicely encompassed the overall scenario with respect to ethanol economy in India. So it also gives me an opportunity to move forward and skip the part of the ethanol economy as such. So I will not dwell much on what exactly the ethanol economy is and what are all the sources. Instead, I will take a little deep dive in the research part, what is going on. So we all know what are all the ethanol productions happening all around the world, where US happens to be the major producer of the ethanol behind and then the Brazil. Major contribution or the major consumption of the crude oil which goes in our Indian economy is from the petrol and diesel, wherein the diesel happens to be for the heavy vehicles majorly going on, whereas petrol goes into the two-wheeler. So as Dr. Devendra said, it's a very attractive to look at this particular sector for the ethanol economy front. Also, the different presenters have given you the technical challenges with respect to the ethanol fuel engine, which includes the fuel economy part, emissions coming out, then the reactiveness of this ethanol, which demands a very specific material to be selected for the different components of the engine, and that is something which industry has been working consistently, and they have got certain solutions that has been going on. So these technical challenges for the ethanol engine development, whether it is 10%, 20% or 80-95, that's what we are discussing. Few of those issues require that you need to look at the lower energy content of the ethanol. Then, since it is a highly reactive material, ethanol being a highly reactive material, you will have to select components of your different systems, like the fuel systems, injectors, pipes, and then think about your material deposits. So a material selection and characterization will be very, very important part. On the running engine portion, you will have to look for the higher latent heat of vaporization for those ethanol, which creates issues in the cold and hot stratability parts, and there can be certain solutions which we will have to be looked into. I'm not going to dwell on those portion. Instead, I'm going to look at combustion and emission characteristics of these engines, which are going to be completely different, and I'm more on the front that what best can be brought out of the ethanol that I am going to look at. Now, we as a combustion engineers or the engine development engineers, we all know that the bottom line for improving the engine performance or getting the maximum out of each drop of the fuel that you put in the engine, whether it's diesel engine or gasoline, it all depends on the air-fuel mixture formation. Two different engines that we encounter, homogeneously charged and the diffusion flame in case of gasoline and diesel engine respectively. They have their own advantages and disadvantages, and accordingly it goes on. The important aspect of both these combustions, both these different engines on combustion, is their emission characteristics are completely different. When you talk about gasoline, major problem comes in the form of NOx emissions, HC and CO, which can be resolved very easily using a catalytic converters. But when it comes to the diesel engine, which happens to be more efficient, we face a huge challenge when it comes to a problem that NOx and soot both are contradicting to each other, and we cannot control it. One of the technique that which had come for last few decades is the low temperature combustion. We know that in case of the diesel engine, because of the inherent combustion mode, which is a diffusion flame, we encounter both soot formation, which is mostly coming from the rich fuel zone, and NOx, which comes mostly from the zone where abundantly available oxygen is there, plus high temperatures are there. Okay, so conventional diesel combustion engine passes through both the zones of soot formation and NOx formation, and then there are certain area where the soot which is formed gets oxidized and little bit less soot is emitted back into the chute. Now we know bottom line or the underlying problem for this is because of your diffusion kind of a flame or uneven distribution of the air and fuel, not non-homogeneity associated with it. So what can be done? The first thing which came to resolve the problem was a homogeneously charged compression ignition engine, where the air fuel mixture was formed prior to the combustion. So homogeneous air fuel mixture is formed and then it is burned. Of course, it had a minimum or no NOx and soot emissions, but the operation limit of such combustion was low. From this point, a lot of work started growing in the area that can we do combustion at slightly lower temperature than that what happens in the conventional combustion engine. At the same time, we burn the entire fuel because it is happening at lower combustion temperature. The NOx formation was avoided or minimized. At the same time, when it is happening at a lower lean air fuel mixture, soot formation was also avoided completely. The key to the such a combustion problem, achieving such a combustion in the engine was air fuel mixture formation, which is not very easy when we talk in case of the HCCI engine, and various concepts started coming into the scenario, research domain. One of the concepts was, can I combine diesel and gasoline, both the fuels, and achieve such a combustion, what we call as a low temperature combustion engine in this case. Why diesel and why gasoline? Now we all know that. See, the diesel, which promotes auto ignition with high CTN number, we call as a reactive, whereas gasoline, low reactivity fuel, which prevent auto ignition because you have high auto ignition temperature. Now combine both of them and achieve what we wanted, the air fuel mixture at the start of the combustion to be more or less uniform or homogeneous mixture by combining the properties of this fuel. Now here comes my take over this particular case is, when we are trying to replace gasoline with the ethanol, can I use it as one of a reactive, low reactivity fuel in the diesel engine and come to a solution where we will be able to reduce NOx and soot emissions simultaneously, achieve low temperature combustion, and at the same time achieve what we are looking at, the ethanol economy, without disturbing any other portion. Instead, I am looking at ethanol as one of the fuel which will help me to clean up the diesel engine combustion from NOx and soot. So that was the point which I was looking at. Once again, look at the basic flame. How does it happen? In the conventional combustion engine, you have the liquid fuel coming into the hot air gas, hot compressed gas. Now this liquid fuel, by virtue of the atomization and the spray, it starts evaporating and forming an air fuel mixture. Now since it's all happening by diffusion, you always will have a rich air fuel mixture in the core, whereas lean air fuel mixture at the periphery. And there is a time when this combustion starts. Now once the combustion starts, you will have rich air fuel mixture sitting inside the combustion flame, which will tend to form more and more soot. Whereas at the edges where the lean air fuel mixture is present, because of the temperature, high temperature, local temperatures, it will tend to form the soot. This is the phenomena which we wanted to avoid. What can be done in that case? So before combustion starts, can you extend this auto ignition, ignition level, such that more and more fuel gets mixed with the surrounding air, and you form the linear fuel mixture. That is where low temperature combustion phenomena comes into picture. So you have a fuel which has a high auto ignition temperature, so that it gets more and more time to mix with the surrounding air, and you can avoid those pockets of rich air fuel mixture which tend to form the soot. Now invariably, just by virtue of giving more and more time, what you are doing, you are trying to provide more and more lean air fuel mixture, or the mixture that is formed will be with a high amount of the air, and that will produce lower temperature, hence avoiding the NOx. So that is what we are trying to reach. Here is a NOx and soot both are simultaneously reduced. Definitely, there has been a lot of techniques which want to achieve this. One of the technique is EGR, providing EGR, where you try to provide a hot air fuel mixture, make lean air fuel mixture, and hence they delaying the combustion. Second thing is, you instead of injecting in a single go, you put it in a multiple injection. So a first injection gives at a lower compression ratio, so it provides more and more time for the air fuel mixture to form, and then the second injection controls the rate at which the fuel is being burned. Or other ways is like you use the gasoline, ethanol, such kind of the mixture fuels to prepare homogeneous mixture and use gasoline diesel to ignite such mixture. So different techniques are being tried and validated whether you can run such an engine for a wide range of operating conditions. So one such attempt we did with the ethanol blending. The first thing which we realize now is the air fuel mixture formation. Our air fuel mixture formation has to be much better than the existing diesel condition. At the same time, you are also looking for a sustainable fuel. So look at the biodiesel as a substitute for diesel, and see how you can improvise the air fuel mixture formation through the spray characteristics. So we did that exercise with diesel, biodiesel. This was a neem biodiesel. Then blending the neem biodiesel with 30% gasoline and then 30% ethanol. So let's look at the gasoline and biodiesel. So if you compare these three sprays, these are the one of the instances at which we have noted and putting up the spray. If you look at the ethanol spray, the cone angle is pretty much good compared to that of the diesel and then biodiesel gasoline flow. We will not even consider the pure biodiesel because of its low cone angle and high tip penetration, which may not be a good idea at this point. So this gasoline and ethanol, both the sprays look in the similarity, but this is not something which was interesting. What interesting we observed was, we were expecting that ethanol should play some role here. This is what we observed when we did this injection. Instead of high compression ratio, we did it at the ambient pressure condition, and we realized that such ethanol spray, biodiesel ethanol spray, 30% or 50%, provide something what we call as a flashing spray. So now if you compare diesel or biodiesel ethanol spray has a very, very wide angle, and it looks something which was you might have observed in case of the PFI injection or gasoline injection case. Because of its nature, you see that very high cone angle, low tip penetration, which is something which you will be looking for preparing the mixture for the low temperature combustion engine, and that was what we were looking for. Latter part, when we did the theoretical analysis, we realized that ethanol having vapor pressure condition, it gets into the cavitation mode and creates bubbles, which ultimately disintegrates the entire spray as immediately when it comes out of the nozzle, and that's the beauty which was seen only in the ambient gas condition. Something which we didn't like, because as we kept on increasing the ambient gas density, that phenomena was tending to vanish, and we were approaching more towards the diesel spray. But nevertheless, that is also a good observation. That was also sufficiently good. What now we realize that it is a phenomena which happens only under the certain conditions. So the temperature and pressure will play a very important role, and there will be certain conditions under which you will be able to observe such phenomena in the blended fuel. Not only that, we have also reached to a point where diesel and biodiesel ethanol blend spray, they were looking more or less similar. So advantage of having ethanol or by low reactivity fuel with biodiesel as a high reactivity fuel will automatically come by achieving my air fuel mixture formation at the same time getting the reactivity. So we also went ahead with the engine test. Now before that, we decided that let's study exactly what happens to the ethanol and in the biodiesel ethanol blends when we prepare a droplet and starts heating it, because the temperature will play a very key role here. If the high temperature fuel or the low temperature fuel enters into the hot gases after the compression, what happens to the droplet? So the study was conducted where a laser was used to heat the single droplet and see the evolution of this. So let's look at the ethanol droplet, which was heated by a 7.5 millijoule laser and 1 mm droplet. So you can see that the moment laser hits, you get a kind of a bubble which is developed inside, because now the laser is concentrated in the center. It evaporates ethanol and then the bubble is created inside. Now this bubble is unstable and it shatters the entire droplet into small droplet, what we call as a atomization or the flash bursting of this droplet. So that was one thing. Now we went on to look at rapeseed biodiesel and ethanol. So this is 30% ethanol in the rapeseed biodiesel. Of course, biodiesel did not give you much of the good result, but when we incorporated ethanol as a blend, what happens is now this droplet is shattered drastically, what we call as a complete rupture of the droplet by forming a bubble inside, and then that ruptures into a very fine droplet in this case. Of course, this is in the atmospheric condition. This is with the 7.5 millijoule higher laser energy burst this droplet in a very small fine droplets of around 10 to 20 microns, which is what we wanted to achieve. Now, what we realized with the entire exercise is if your droplet actually encounters such an environment, which is possible inside the combustion chamber, if you are doing it the split injection, or if you are providing the ethanol, the blend at higher temperature, you may achieve a single or multiple droplets breaking will fragment your entire spray and will prepare the required air fuel mixture. But that's all still possible, and then the work is going on. Now, we did a theoretical analysis, and then just to show you, if it is a biodiesel droplet, you can see that it doesn't break. Actually, it only shatters slightly and then moves out there. Sorry. Yeah. Okay. So then we also did this fragmentation study with the RE30 and all. The results of engine test gave us sorry, why it is yeah, result of the engine test gave us a very encouraging part. One thing is, when we go for the ethanol blend, by virtue of its delayed atmospheric ignition, it gives you a very low rate of heat release. That was very important finding, because in case of the homogeneously charged compression ignition engine, that is one of the major challenge, controlling the rate of heat release. More importantly, when it came to emission test, these are all the constant load, constant speed condition. We could achieve the points where very low soot and NOx could be achieved. Of course, these are all the preliminary studies, and a lot of work is being done or required to be done to increase the load range and the speed range. But we have got to a point where you can try to reduce or minimize soot and NOx emissions as much as possible when it is coming out of the engine. And that also means that you can avoid having a very costly after treatment devices which are put up in the diesel engine. We also did a lot of studies with gasoline, methanol, CNG being my secondary fuel, and the work was done. So I'm not going to get into more details, but another study, a very extensive study, which was done on a multi-cylinder engine using gasoline as the secondary fuel, which was injected in the intake manifold, and diesel to ignite with a varying percentage of gasoline and gasoline from 0% to 85%. What we got is you could reduce soot and NOx significantly below that of the emission norms, legislative norms which are put. But there was SC and CO penalty, which was coming out apart from a slight increase in the BSFC of such engine. But that also gives you an idea that there are avenues through which you can use ethanol and gasoline to reduce the emissions significantly from that of the diesel engine, and it is very much possible. So what we realize is that somewhere around 70 to 85% we can get to a point where significant reduction in the NOx and soot emissions for the diesel engine can be achieved, and now this diesel can be replaced with that of the biodiesel to go. So now the way forward for ethanol fuel implementation is ethanol should be explored as a fuel to improve the fuel economy and emission also. So that should also be one of the way how we should be looking at ethanol. Blending ethanol with diesel, biodiesel or gasoline can be an effective way to improve the performance. One of the important characteristics or the point which I wanted to highlight was cavitation-induced flashing spray for the blended fuels can be one way of improving such combustion performance, where near zero NOx and soot emissions are possible in the low temperature combustion zone. So fuel air mixture formation, reactivity stratification and delay in the start of combustions are the most influencing parameters or the key to achieve this combustion control. So that's where I will like to leave this part. So ED95 or the ethanol additives is also coming up as an option to the diesel. However, complete new design will be required under such circumstances. So I'm not actually looking at it, but what point I wanted to mention is like one will have to look right from the scratch or the spray formation, the fuel injection system, and then the combustion when we want to go for the for such engine development. And as rightly mentioned by Dr. Thipse, that these cases has to be looked in the perspective of the Indian scenario, because we have a completely different environment and different complete geography, which puts us in a different perspective to look at the problem, and hence we cannot just buy a technology and implement it, but we will have to look at it in the more details and get appropriately or modify it appropriately for the Indian scenario case. So that's it from my side. If you have any questions, I will be free to answer. Thank you.
Thank you, sir. Thank you for the wonderful presentation, and thank you for the study data that you could share with us, and we are grateful to you. Now it is the last presentation for this session. May I call upon Mr. Dinesh Kumar. May I request him to share his presentation? For that, I would like to introduce him. Mr. Dinesh Kumar, he is the Vice President, Air Purification R&D of Sud Chemi India Private Limited. He is heading the R&D division, and he is responsible for development and evaluation of TWC, DOC, DPF, SCR, etc. for purification of automotive exhaust. He has over 44 years of experience in research and product development of IC engines. He possesses a depth knowledge on engine combustion process and emissions, and has comprehensive analytical and experimental experience on design and performance optimization of diesel gasoline engines and use of alternate fuels. We are honored by your presence today with us, sir. May I request him to kindly share your presentation with us. Thank you, sir. Kindly unmute yourself, sir. And
hello, is my screen visible?
Yes, sir. Kindly in the display settings, you can probably duplicate the screen so that the presentation is visible. Yeah, yeah. Yeah, your slides are visible.
Good afternoon, everyone. At Sud Chemi, we manufacture the catalytic converters and supply to various OEMs. with the announcement of preponement of implementation of E20 ethanol blends, we took in-house study to study the effect of E20 fuel on emissions, particularly the aldehydes. So today I will be presenting a brief study which we carried out. It is a very short presentation on that. I will be just like all the previous speakers have covered, and this is also from the literature, the impact of ethanol blend in a various ratio and how it impacts on the CO, NOx, and other emissions. So as it has been seen, like by increasing the percentage of a blend ethanol content, the PM 2.5 and the CO both are on having a decreasing trend. Actually, it is because of a high oxygen content and the low C2H ratio of the ethanol, which makes the lower CO and PM both. Nitrogen oxides is normally is proportional to the engine power output. As we see that with the ethanol blending increasing to E20, we see there is an increase in NOx content, and with E85 and E100, the NOx is getting reduced. So it has to do with the basically the power output. And at a constant air-fuel ratio, if we see that cylinder combustion pressure and temperature increases, mainly it is because of a high flame speed, and combustion gets completed in a shorter duration time, and peak pressure may be occurring around TDC. Hence, that results in increase in NOx when the blending is there. With increase in the ratio or E85, there ethanol being the lower, having a lower heating content, large amount of ethanol has to be injected. So that large amount occupies the space inside the combustion chamber that results into the lower power, and hence we see a lower NOx emission. And mainly it comes even because of high latent heat of vaporization also. Of course, that tried to increase the power because we could have a higher volumetric efficiency because of that. And with the lower heating value, like the average per liter or mileage per liter decreases, although the thermal efficiency with ethanol may be a bit higher than the gasoline because of the presence of oxygen inbuilt. And octane number of ethanol is quite high. And with addition of this ethanol into the gasoline blend, the octane number increases. And the large benefit of this can be utilized if we optimize the compression ratio and optimize the timing to suit to the engine. So as I mentioned, like in-house, we did some studies, and we took one BS6 two-wheeler to whom it is fitted with the should chemical catalyst. And we plan a study on two fuels, like we took one commercial gasoline, E5, and E20. By blending additionally ethanol into it, we make it E20. And we did a study without catalyst and with catalyst using HORIBA mass emission analyzer for measurement of a mass emission for the regulated emission components like CO, hydrocarbon, NOx. And we have used the Thermo Fisher FTIR, by which we have measured only the raw emission, particularly targeting aldehydes, formaldehyde and acetaldehyde, and seeing the impact of increasing the E20 ratio, how it impacts the engine out aldehydes, and what happens to the after the catalyst. So this one is the simple mass emission measurement, and we see in the traces like E5, which is represented with red color, and E20 with green color, like there is a reduction in the CO as well as the hydrocarbon, although we see some peaks of the NOx, which is increasing the NOx emissions. And this is in a tabulated or bar chart. And overall we see there is a drop in CO by drop in CO. These are the raw emissions. Initially the raw emission measurement and after the catalyst, which has been given over here. So in raw emission, like the CO decrease is there about 110 milligram per kilometer, and finally after the catalyst, the gain is about 50 milligram per kilometer. Similarly, for hydrocarbon, the gain is about 50 milligram as a raw emission, and with the catalyst, after the catalyst, 10 milligram gain is observed. On the NOx, there is an increase of 10 milligram, and after the catalyst also that is maintained. But still the NOx emissions are within V1 limit. So there is a, it may be in some cases one may require a fine tuning for the reduction of a NOx finally when it gets implemented. Otherwise, and few cases may clear without doing anything to the system. Here we see that the comparison of formaldehyde as well as the acetaldehyde emission pre-catalyst with both E5 and E20 blended fuel. So with E5, the formaldehyde emissions are more or less same with both the fuels, although we see increase in acetaldehyde emission with E20, that is before the catalyst. And after the catalyst, like the commercial catalyst which is being used into the BS6 vehicle, which is again a fuel injected and of course closed loop, so lambda is taken care by the system. And here we see that formaldehyde as well as the acetaldehyde, barring in first 100 seconds till the light off is achieved, we see more than 90% conversion in both the cases. In the next slide, we are taking a comparison of E20 fuel, like engine out without having a catalyst, and after the catalyst with E20 fuel. So we see there is a increase in aldehyde emissions ranging between 15 to 20 ppm, and after the catalyst it is practically 0 or 1 or 2 ppm we can see on that. And acetaldehyde, again, although the level is touching around 100 ppm, and after the catalyst it is being reduced to very, very low value. So we simulated these studies on the synthetic data. There we introduce in synthetic mix up the different gases which are present into the exhaust gas, and we added around 47 ppm of formaldehydes and 78 ppm of acetaldehydes, and testing the rig at lambda 0.993, where lean and rich pulses were simulated just like a closed loop system of a gasoline engine. So we see that after the light of temperature, if we see around 50, it is around 200 for acetaldehyde, and formaldehyde it is very less, about 150, 160. And once the temperature crosses around 250, and we see there is a good conversion of both. But we also see that there is a formation of methane. Acetaldehyde is getting converted, part of the acetaldehyde gets converted into methane, which gets oxidized after 500 degrees centigrade. And once below graph shows the conversion efficiency and of the different component, and we see that the conversion efficiency of a... Hello?
Sorry, sir, I request you to conclude because we are running short of time.
Yeah, I'm complete. This is the last one. So we see that more than 90% conversion efficiency to the things. On the conclusion, this is the last slide. The mass emission measured before and after the catalyst shows that lower CO and lower hydrocarbon emissions and higher NOx emissions with E20 fuel as compared to E5. That is in line with the literature. And hydrocarbons are 10 milligrams lower, and NOx is 10 milligram per kilometer higher than E20 fuel. Formaldehyde emissions are nearly the same as E5 and E20 fuels, although the acetaldehyde emission with E20 fuels are higher with BS6 fuel, and Catalyst has converted these aldehydes with 90% plus efficiency. And the modal gas test reactors show that greater than 270 degrees centigrade, 90% acetaldehyde and formaldehyde gets converted. Methane is formed with the conversion or oxidation of acetaldehyde, which is oxidized to about 90%, exceeding the 500 degrees C temperatures. Thank you very much. Thanks for giving me the opportunity to present a brief presentation.
Thank you, sir. Thank you very much for your presentation, and we are grateful for your the study material that you could share with us, and the aldehyde emissions that are foreseen in with ethanol. So thank you for the wonderful presentation. As it is well said that difficult roads often leads to beautiful destinations. So this has been an eye-opening for us as the presenters clearly explained the challenges in front of us and on the ethanol economy road, and with the hope that a beautiful destination that lies ahead of us. I sincere thanks to all the presenters and the knowledgeable presentations that were shared with us. With this, we end the technical session. And now we are going to begin the panel discussion. And I would request Mr. Dipanshu Dev Sharma, the editor of Mobility Outlook, who is with us today. Thank you for your presence, and we all know you, and as you are a very known face in auto journalism, and I wouldn't take much time in introducing you, and we are privileged to have you today to moderate the session and this panel discussion on the topic challenges for auto industries of ethanol blended fuel EBF policy. And over to you, Mr. Dipanshu.
Thanks very much for that kind introduction. Hello, everyone. Welcome. I know we are running a little behind schedule. We were supposed to actually close the session by 5. What we'll do is we'll extend it to about 5:25, 5:30. So in the given time that we have, we will try and cover the subject adequately. And without much ado, I would head straight to this session. So greetings, everyone. At the outset, a quick thank you note to ICAT for inviting me to be part of this important webinar on ethanol economy. It is indeed an honor. I will not go through the details. I mean, since the start of the webinar, we've heard about the expert committee report and the various targets that have been set for the industry. Now, to discuss the challenges for the auto industry from a holistic perspective, looking at technology, product, refining, distribution, and policy, we have with us today a panel of eminent experts. So please join me in welcoming Dr. Anjan Roy. He is the director at the Indian Institute of Petroleum, a graduate of Indian Institute of Technology, Delhi. Dr. Ray received his doctorate in chemistry from the University of Pennsylvania under the guidance of Nobel laureate Professor Ellen McDermott. Dr. Ray is the 8th director of CSIR IIP. Dr. Ray, welcome. Moving on, our next panelist is Mr. Harjit Singh. He's the executive advisor, technology at Hero MotoCorp. Mr. Singh has over 42 years of experience in the automotive industry, and for the last 33 years, he has worked on various new product development projects at Hero MotoCorp, and also as the head of R&D with effect from the year 2000. A BTech in mechanical engineering from IIT Kanpur, he has also attended a number of training programs organized by leading institutes. Our next panelist is Mr. Anup Bhatt, Executive Vice President Engineering at Maruti Suzuki India. Anup is a mechanical engineering graduate from Regional Engineering College, Kurukshetra, and currently he leads the powertrain development and engineering vertical at MSIL. He has been associated with Maruti Suzuki for the last 25 years and is an active member of the Science Committee on Emissions and Conservation and is Vice Chair of Seminars and Conferences Committee at SAE NIS. Moving on, our next panelist is Mr. P.K. Banerjee, Executive Director, Science. He is an alumnus of IIT Mumbai, having over 30 years of automobile industry experience. He has extensively worked in different capacities of engineering, development, localization, advanced technologies, certification, regulations, and standard formulation roles in multinational companies. He is also a member of the Governing Council of Society of Fuels and Petroleum Laboratory, Noida, Society of Automotive Engineers, India, and a fellow of IMEC-E, London. We have already been introduced to Mr. Dinesh Kumar from Sudkemi. Mr. Kumar joins us as a panelist as well. Moving on to introduce Mr. K.U. Ravindra from Bosch. He started his association with Bosch Limited in 1995 and has more than 25 years of experience in the automotive domain. During his tenure, Ravindra has worked mainly in product development and testing, combustion development, and since 2010 is also responsible for powertrain system engineering. He also co-holds patents in the field of automotive. Our final panelist is Dr. R.K. Malhotra, Director General of FIPI, a mechanical engineer from IIT BHU and a PhD on energy studies from IIT Delhi. Dr. Malhotra was earlier board member at Indian Oil Corporation as Director R&D and also held additional charge as Chairman before superannuation in June 2014. He has more than 42 years of experience in the oil industry and has authored and presented more than 200 research papers and holds 138 patents granted in India and abroad. Welcome, gentlemen. Welcome to the panel discussion. So, when we look at the in fact, our Prime Minister, Mr. Narendra Modi, has said that ethanol has become one of the major priorities of the 21st century in India. Of course, there are multiple attractions, reduced fuel import bill or potential benefits for farmers, and of course, ethanol being relatively less harmful to the environment than other fuels. Now, despite these potential advantages, rolling out ethanol blended fuel isn't going to be easy. So, in this panel discussion today, let's get the panel's perspective on the challenges that the industry faces in meeting the proposed targets with ethanol blending in India. So can we start with you, Dr. Ray?
Yes, of course.
And I request actually, for the want of time, I request each panelist to limit your comments to about 3 to 4 minutes so that we can get into some Q&A later. Thank you.
Are you able to hear me clearly?
Yes, Dr. Ray, please go ahead.
Thank you. So I think I will start with the very basic question of how many ethanol standards do we need? Today we are talking about a wide range of ethanol deployments, and there is a simple trade-off. The more blend options that you have in the market, the wider adoption you are likely to get, because the supply chains are not uniform across India. And the fewer standards and blends you have, the more improved engine reliability and simpler supply chains that will accrue. Mr. Harjeet Singh, who's a co-panelist, and I go back many years ago in BIS, we were debating the fact that India is a two-wheeler economy and that the more precise the ethanol blend in every two-wheeler, the better the chance we will achieve our objectives. The second point that we may wish to consider is that therefore, at least in the long term, we should have minimum number of standards, but in the short term, intermediate standards, E10 and E20, will be seen as medium-term measures. Because flex fuel, as we have seen from the Brazil example, is a pragmatic approach. However, as the speaker from Maruti Udyog highlighted earlier, the end user has to be made aware of the issues and required precautions. This will ensure that as we roll things out, we get better consumer acceptance. And this awareness building exercise is often something we do not focus adequately on. I would say that awareness building is crucial to success in this story. The second aspect that I will touch upon is the handling and storage, which again, many speakers mentioned. Let's keep in mind that ethanol is something that tends to accumulate water. It's hygroscopic. At E85, you can get water separation.
then associated risk with that is that the flame visibility of ethanol is poorer than gasoline. So in the potential event of a fire in ethanol transport before blending or in high ethanol blends, we must have suitable training to ensure that ethanol fires are properly detected. Similarly, it has different explosion limits from gasoline. So gasoline, typically the explosion limits are from a lower limit of about -41 to -10. Whereas for E85, it's more like -33 to 11. Therefore, we have to take extra care with high ethanol blends as we move towards a flex fuel model. And we've heard from most of our speakers on material compatibility aspects, so I will not go there. On the plus side, with all the issues that are tabled by now, the problems are well known and the industries are working collaboratively for solution. I will simply say here that the one thing that has been missed and where I would recommend much more additional research is the impurities from feedstock and process, because we're moving to a multi-feed ethanol economy. As we go from 1G ethanol to 2G ethanol, as we look at more grain ethanol, more starch ethanol, and potentially we look at even planting more energy crops that can give you ethanol, the impurities that are produced and the emissions thereof, as we just heard from Sudhkami, for example, will change. And our understanding of the impurities in ethanol versus its performance, its behavior in terms of the engine and on terms of the fuel path, in terms of storage, and in terms of the final emissions that the ethanol blended gasoline will give. These need to be much better understood because we're talking about a much greater complexity than, let's say, the Brazilian economy today. So with these few remarks and exhorting greater attention to the three aspects of clarity, communication, and coordination, I hope I have taken less than my 4 minutes. I would like to pass it back to the moderator. Thank you.
Thank you, Dr. Ray. Very clear thoughts indeed. We will move to our next panelist, Mr. Singh. Mr. Harjit Singh, can I invite you for your initial comments?
Am I audible?
You are, yes.
Thank you, Dipanshu, and I'll take a minute extra to talk about, make a statement that I believe ethanol blended fuel is a 360-degree win-win situation for all stakeholders. How to justify that? There is something in for everyone. Look at the government. It's a green fuel, reduces oil import bill, reduces carbon footprint, helps in CO2 reduction, and the big ticket item, it enhances the farmer income. Something for the customer. It's an indigenous fuel, so not impacted by international oil prices and currency fluctuation. Hence, it is a much stable prices. Recently, we have seen the havoc in the gasoline prices going up and up. OEMs. The biggest in for the OEMs is that it increases the life of the IC engine technology itself, because otherwise it comes under a challenge. CO2 benefit for a CAFE norms is the OEM's intake. Environment, the biggest beneficiary, stands to gain a lot. So that's what I call it, a 360-degree win-win situation. Now I'll talk about 4 or 5 challenges. One of the biggest challenge, I believe, is the uncertainty. We have been hearing from the morning or since Dr. Kumar started that E10 implementation history started in 2003, and even in 2021 we do not have a 100% E10. We are talking about soon by next year we'll have 100%. So confidence is low. That's the biggest risk or a challenge. SAM had requested for a notification to be released, in fact, in this year, somewhere in February, March, for E10 Pan India by 22 and E20 Pan India by 25. And SAM has submitted, even through a white paper, our commitment that SAM will have a E10 fully compliant and E20 material compliant vehicle by 24, starting development in 21. We have taken 3 years of a development time, the toughest development time which was taken for BS4 to BS6, because the amount of development is very similar, hardware change and a recalibration. And E20 full compatible by 26. And third request what we have made is E10 to continue as a production grade fuel, which now has been recommended till 2025, and we are still now discussing this. The biggest question comes here. The challenge for auto industry is, how can we start the development in absence of any document in our hand? So that's one challenge. Second, I call it a customer. Customer actually is the biggest victim. Today, vehicle on road, we call it E10 material compliant is a misnomer. I request everybody always to call it is a E10 material compliant and not performance compatible. E10 has been implemented in large part of the country, though the country average is around 8.5. And the biggest dilemma with the OEMs is, if customer comes and asks us, okay, Mr. Hero, please tell me, is my BS3, BS4 vehicle E10 compliant? What answer can I give? I cannot give yes, because that's wrong. And if I say no, it is strategically wrong. So that's the biggest dilemma we have. The customer is getting roughly 3 to 5% lower fuel economy, even on E10. But why should he suffer? Isn't a sort of a cheating to a customer? The only thing is that such a small difference in the fuel economy, he cannot perceive it. But if you measure it scientifically, you can actually quantify it. Is 3 to 5% is a second challenge. Third challenge is what will happen to the vehicle which are already on road. And once E20 is launched pan-India by 2025, because we haven't fundamentally designed the vehicle for E20. Luckily for which now, where the SAM has requested for E10 as a protection grade to continue till end of the life of the vehicle. But now one experimental is being done between ARI, IOC and SIAM, and I'm sure it will depend on the results of outcome of that. The fourth big challenge is a flex fuel vehicle. That's a real challenge. Because in India, we don't have experience. We do not even have actually designed even E10 fully compliant, and we are talking about full flex fuel vehicle. We have been hearing the flex fuel vehicle understanding of the policy maker is 100% gasoline to 100% ethanol. Actually, ethanol is a 93%, because E100 ethanol, as someone has already mentioned, is unsafe because of the flame not being visible. Hence 7% additive, either gasoline or additives or even water is added. So then only it becomes a E93, which can be used in the automobile. One of the member among SIAM who have a presence in Brazil, they have shared the experience of design complication. If you go for E100 or E93, the cold startability is so severe that there is a lamp which pops up and says, please add more gasoline to reduce the ethanol percentage so that startability improves. And why to have E100 or E93 at all? There's only one country to the best of our understanding, and that's Brazil, which has E100. No other country has it. We don't know the reason best known to them. So hence we are requesting to limit the maximum ethanol to 85%. And SIAM has also agreed to develop flex fuel vehicle between 82 to 85 and do not go beyond that. The fifth one and the last one for the two-wheeler, which is OBD2. Nowhere globally there have been E20 for flex fuel vehicle with BS6 or Euro 5 norms with OBD2. So that means Indian OEMs have to do their own research and develop their own solutions. So these are the 5 items which I would like to throw open. And of course, I have a measure also. I think in the next round, we will talk about that. Thank you.
Thank you, Mr. Singh. I'll come to, we've got the two-wheeler perspective. We'll also get a four-wheeler perspective from Mr. Anup. But Anup, Raman-san in the inaugural already has talked about certain concerns that exist on the ethanol front. I would like to understand from you, how do you look at these challenges for not just for the company, but also for the proper four-wheeler perspective?
Thanks, Dipanshu. Am I audible?
You are, yes.
Okay,
yeah.
Thanks. I think Harjit-san summed it up quite well, but I'll put it a little differently. I think we have to look at challenges, but the challenges sometimes come from lost opportunities. So what are the opportunities that are in front of us? I think what Raman-san also shared is 1,400 crore liters of blending in 2030, a possibility, with E20, just E20, and additional 300 crore liters with FFVs if we start from 2027. So that is 1,700 crore liters. And nobody in the first session talked about 1,700 crore liters as a possibility. So it's an opportunity which is in front of us. There's 5.1% blending, which has been done last year, 7.9% in the last month. And Ramkumar San, he talked about 8.5 for maybe this financial year till now. But the opportunity is to go to 19%. That's our calculations. If we are able to do 1700 crore liters, so it's roughly going to be around 18-19% of blending. So that's a huge opportunity for us. Along with that, India is also talking about GHG reduction of carbon intensity. With this kind of blending of ethanol, we see a possibility of reducing the GHG intensity from passenger vehicles and from gasoline-driven vehicles by 6 to 7%. So it's not a small number; it's a huge number, and which, of course, results in the decarbonization of our vehicles, whether it's about the life of the vehicles or the IC engines getting expanded or extended. So that's, of course, a benefit from that perspective. And there's the other benefits that government keeps talking about, whether it's the farmer's income or whether it is the sugar subsidy issue, which is generally talked about. So these are the opportunities. So what are we missing? I think what Mr. Harjit San talked about is uncertainty. What Mr. Ray talked about is how many blends do we need? All of these are uncertainties. So what is the uncertainty playing here? Is the kind of fuel which we are going to deal with. Now, as Harjit San put it, I'll put it in a slightly different fashion, that there is an engine which is under development in our lab today, and it is being developed with E10 fuel. Why is it being developed with an E10 fuel when government is talking about E20 fuel? Because we don't know whether E20 would be there or not, one. Second, we don't know whether RON 95 with E10 is going to be there. We are asking for it. We are saying at least commonize the RON for 90 with E10 and E20, so that if there is any slip in E20, we don't have to redo the development process. So we need certainty. So what is the loss of opportunity here? So if you're talking about 13 million metric tons of fuel saving in a good scenario, you would actually lose 5 million metric tons if we live with this uncertainty. If we keep on calibrating our vehicles with E10 fuel and RON 91, so that's a lost opportunity for all of us. I think what Harjit San talked about is a 360-degree benefit. All of us will lose actually if we live with this uncertainty. Customers will lose. So customers will lose what? 5 to 7% of fuel economy, whereas actually with E20 fuel, and whereas actually we can actually limit it to around 2% if we are able to develop our engines to be able to run with E20 fuel. So the uncertainty is going to result in non-optimized engines, and the customers are going to lose. The government is going to lose because we will not accrue the benefits of ethanol, and we will not have gains in GHG to the extent it's possible. So the ethanol presents a huge opportunity for all of us. So it's up to us to harness this this opportunity. Now, what are the other challenges which are there? Of course, we are working on BS6 Stage 2 and CAFE. I think the entire industry right now is working on it. Even doing the E20, meeting the commitment of E20 by 2023 is a huge challenge that we see in front of us. And on top of that, if we are talking about a flex fuel development, which is a completely new development, I think from an engine perspective, it's a totally different engine altogether, right from pistons and rings and fuel injection system, heaters, and whatnot. So I think the previous speakers, Dr. Agrawal and the other speakers, have already talked about different character of this fuel altogether. All said and done, it's a cleanser. Ethanol cleans the fluid, the engine. It doesn't allow for lubrication. It'll have impact on valve seats and wear. It will have impacts on scuff and rings and so on. So engine reliability has to be improved. And what we also understand from discussions with people who have actually developed flex fuel vehicles is that you should always develop it with the actual ethanol, not with a chemical called ethanol. So with the actual ethanol. And as I hear Dr. Anjan Ray also, there's going to be ethanol coming from different feedstocks. Maybe they may also differ in character. So we need to be wary of this situation and develop engines. So there's a lead time which is required for this development. It's not that a solution is there and we can simply adopt it, copy it, and use it. No, it's not like that. So you'll have to develop your own solution for India, and keeping in view the Indian customers. So and the last challenge is the current customer base, which we already have. So I think what Raman San also talked about, Harjit San also talked about, is that there is a huge customer base who are running vehicles with E10. So what is it? If he goes to a fuel stand where he's getting E20 only, so how is he going to react? Is he going to fill fuel or is he not? So although there are talks about doing these studies and all that, but it's about reliability. It's about years of experience and development, and not about 2 months of quick dipstick check to say that okay, it works or it doesn't work. So I think looking at these challenges and the opportunity, the way forward for all of us is one, a BS6 level of clarity of fuel availability and specifications, both. A BS6 level, I want to repeat it actually, BS6 level of clarity of fuel. Like 2020, 1st April, we will have BS6 across the country, mandated. It is documented with Supreme Court and whatnot. So there is a commitment, but that kind of commitment has to be there for E20 as well as for higher blends for flex fuel vehicles. One. Second is a step-by-step approach, and look at the opportunity, look at the way in which we can utilize every drop of ethanol in the most useful manner. It's not that ethanol is going to be free, that you are replacing a crude oil which is imported, so it's costly, with ethanol which is indigenous and it is free. It is not like that. So let us utilize every drop of ethanol to the best extent by making the engines more efficient, while having a roadmap which is clear to the youngest of engineers in our organization what to do with this fuel and how to develop an engine. So this step-by-step approach is something which is really necessary. Declare ethanol as a carbon neutral fuel so that there is a policy which is associated with it. And last but not the least is work on a customer-centric approach. I think Raman San also talked about it. So let's keep customer in the center of all of these discussion, and see that if customer is happy with this fuel, so then the offtake of this fuel, the penetration of this fuel is going to be there. So let's work on this customer-centric approach is the message. Thank you.
Right, Anup. I mean, clearly, you have highlighted the opportunities that exist as well. And while we are talking about challenges, what is needed is clarity for the road ahead. We are going to discuss that in the second phase of this discussion. I'll now move to Mr. P.K. Banerjee. Mr. Banerjee, your initial thoughts on the challenges that you see with ethanol in the country.
Very good evening to everyone. On behalf of Indian Automobile Association, representing all the member companies' interest, I think the first and foremost consideration which government must look while introducing ethanol economy for transportation usage is, one is clarity, second is consistency, and the third one is stability. Clarity means clarity of purpose, clarity of objective, clarity of goals, clarity of methods, and clarity of the roadmap. So when we see that 2030 biofuel national policy on biofuel, 2030 was the E20 target, which was preponed to 2025. Then the commensurate supply chain augmentation, the readiness, the 1G, 2G ethanol, all that needs to fall in place. So when we talk about the clarity of goals, then there has to be a consistency. Consistency means if you decide to introduce E10, E20, flex fuel, then there has to be consistency in all around policy, whether incentivization policy for generation of ethanol, whether allurement to introduce the early technology in, from the customer perspective, the consistency and policy, the movement of the ethanol from one state to another. So policy consistency also has to be 360 degree. So one is clarity, second comes the consistency. And now, after having said that, if the government change, if any other scenario develops which is not leading to a stability, I think the business environment, business sentiments gets a beating, and customers' confidence on the product, the technology, the approach gets disturbed. So therefore, when it comes to stability, then there has to be a long-term stability of the intentions which government is trying to put on the table, and going and moving ahead in terms of objectives, the consistency of policies, and then of course the stability. Now there are three factors which we must have very clearly before us. One is standards, second is regulations, and the third one is policy. Now when we come to standards, even though we have debated a lot, we are still not clear what kind of standards we are looking for. What kind of standards for anhydrous, what kind of standards for E100, what kind of standards for E85, E20. Today we do not know how to blend E20, how to give the commercial fuel, how to give the reference fuel. So standard must be very clear. So first is standard. Now having got the clarity on standards, we need the regulations very clear. The kind of regulations and notifications has been brought out. It needs many changes. Government has agreed to bring changes. They are trying to give clarifications, but a business should prefer always a very clearly, legally tenable statements in the regulations. It can't be, subsequently clarified in a form of a DO or a letter saying that the regulations means this or that, because act is prevailing, followed by regulations and followed by the subsequent actions. So regulations also clarity needed. And the third one is a policy. Right now, what is the pricing policy? What is the policy of incentivization? What is the policy on promoting the vehicles? What is the policy on production incentives? So policy consistency also is required. So from my point of view, since morning, since we started, I think enormous amount of discussion has happened on technology. Technology is not a constraint. For business, technology is available, technology can be deployed, but the investment and the clarity, how many fuels industry has to work on, methanol, ethanol, E20, E10, E12, E15, E85, E100, E93, ED95. So that clarity must be there, and government must decide the priority in the direction in which industry to move. If IC engine has to survive, then the fair degree of clarity should be there, that electrification has to happen at a pace which is reasonable for the industry, and sustainable mobility should be the goal. Distress, undesirable distress, avoidable distress in the entire ecosystem, not only the product change, but transformation of mobility, but also the distress in the employment, distress in the society in functioning, and the leadership position which India is acquiring in different segments of mobility. That should not be given away. So I would stop here and then subsequently come the next round of discussion. Thank you.
Thank you, Mr. Banerjee. I mean, one key point that I wanted to sort of raise with this panel was we need clarity, we need stability, but we also need to prioritize, right? So that is the point that you have already brought about. But maybe I'll come back to the panel to seek your inputs on how should India really prioritize when it comes to our fuel roadmap overall. I'll come to you, Dr. Malhotra, from someone who's been in the oil sector for over 4 decades. Your initial thoughts on not just the challenges, but maybe I could also club it with how do you really see the roadmap going ahead for the country?
Thank you, and good evening to all of you. You said 4 decades of my experience, and I can recall the days, when I joined the oil industry in 77, 78. The very first project together with Indian Oil R&D and Indian Institute of Petroleum, I recall, we did in 1979 was on 10% and 20% ethanol blend evaluation. Dinesh is there, I think he will recall those days. We ran the cars between Faridabad, Dehradun, and we had done very elaborate field trials on old cars, Ambassador, Standard, that time Fiat, and Bajaj scooter was always there, and some of the military vehicles, and we could find that nothing happens to those vehicles, and the trials were successful, the field trials were done. But then there was nothing happened for almost 20 years, and then around 2000, the pilot projects for 5% ethanol started. Infrastructure was built up by the oil companies for blending ethanol, and those 5% work started. But in between, again, there was somehow it got slowed down, and it is only after this present NDA government took over that the ethanol momentum again picked up, and the biofuel revival of biofuel push was given, and that has been given in a very, very big and very aggressive way, I must say. Of course, the government really means to reduce the oil imports. That's one. Second, they also want to reduce pollution. The third, the greenhouse gas emissions pressure, and also the additional incentive through these biofuels is to give to increase the income of our farmers, which is again a priority for this government. So all that, having said that, the ethanol, which is the subject of this conference, is being given a big push. All of us know that. Whether in the auto industry likes it or refineries like it, I don't know. But the government is giving a push. And ethanol earlier was coming only from molasses, which was being produced in the country. Now there is a policy to produce it from grains. The big push is being given from biomass. There is gas fermentation route also available, where the waste gases are being converted to produce ethanol, and that's not coming cheap. It's more expensive than the petrol and diesel which we produce in our refineries. But today, the auto industry is accepting this with open mind. They're ready to look at the 20% blend. They are looking at fuel flexi vehicles. The oil industry is going even extra mile to set up the biorefineries other than the oil refineries. All this is happening at a time when we also have challenges of EVs being coming in a big way. We have the hydrogen mission, the green hydrogen mission, and the fuel cell, everything being talked. So I do sympathize with the auto industry, as Banerjee said, that there are so many things. In a presentation made by Dr. Tipse, I think from ARI today, before this session, he showed that there are about 10, 15, 20 kind of options which are available. So Banerjee Saab, it is not only a problem for the auto industry, it is also a problem for the oil industry. Now, how many blends we can market? This is a challenge for both of us. You have a challenge that how many type of vehicles you produce, and we have a challenge that how many type of fuels we can blend in our depots, how many fuels we can dispense. We have to dispense natural gas from also, then tomorrow you will be dispensing hydrogen, then there is EV charging stations and so on and so forth. Then you have 10% blend, 20% and methanol. Don't forget that. Today morning we had a meeting with the Department of Science and Technology where a project of evaluation of M15 and along with 10% and 20% ethanol plus M15 was also discussed. So which ARI and IUC are going to do. And incidentally, I was chairing that meeting of the Department of Science and Technology for funding of the ARI side. So I also know that there are several challenges, but I think as Anup said very rightly, that it brings opportunities also. So maybe we'll have to work together, the oil industry and the auto industry, sit down together. And I'm sure the government is receptive to whatever we want or whatever we say. And some solutions can always be found, because we have to meet the greenhouse target, greenhouse gas emission target. There is no way out for us. India is committed for INDC targets, etc. But I do agree with all of you that there is a clarity on roadmap required, consistency, stability. I think Banerjee had put it very rightly. All these things are required. And the coordination and cooperation between the auto industry and oil industry is a must. And we together must, strengthen our meetings and come out with some of the, policy initiatives which we look forward from the government, and we must approach the government in with an open mind, right perspective, and I am sure they are going to listen to us. But problems are for both, challenges are for both the oil industry and the auto industry. So it's not only the auto industry which has issues, which we also have for the oil industry. So with this, I think opening remarks, I'll stay here. If you want to some other question later on, okay.
Sure, Dr. Mathur, I appreciate. I mean, of course, like you rightly said, the issues are collective, right? Challenges are collective for the industry. I'll come to the other aspect of the industry, the supplier side. I'll come to you, Ravindra. As from a tier one perspective, of course, you have multiple challenges. I mean, we talk of materials, we talk of calibration challenges, but let us hear from you. How do you look at this whole piece?
Thank you, Mr. Dipanshu. So it's a privilege to be part of this webinar and also with this group with a lot of experience there. So yeah, I'm also representing Component Manufacturer Association. So if I look at that part, I mean, a lot has been already said about the opportunity and things like that. That I compliment. I have no complaints at all. So what I would like to touch upon is a couple of points. One is the ethanol is, of course, it's going to influence several aspects. For example, it's more component development, validation, calibration, supply chain development. So I mean, it is like every aspect you like to look into detail. One more important is validation part. So what we are doing today is, of course, we have E5 and of course shortly E10, and we'll have some experience there. And of course, we need to make experience with higher blend as well. So what we are right now doing is the validation is done initial trials, but we are not looking into lifetime so far. What we should also take care is the end customer. Once we have released vehicle in the market, we should not have recursions there. And one important aspect is also when it comes to specification of ethanol. Water content is very, very important. You can already see what discussions are ongoing in Europe. There is a big discussion about limiting also water content, not only in E100, also in E20. So also recent development in Europe, they also limited this water content mainly, also the logistics part, which is to be taken care precisely, also limiting this water content. If not, there will be a problem in the field with validation. So now when we are doing validation for different blends, we also need the fuel validation for lifetime, and we should be very clear what is going to be the challenge. Of course, we should also look at the components which can make lifetime. So this is one part. So the second part is calibration. So also Anupsan already discussed this. So we have different blends, E10 now discussed, and also E20 coming. And between also there is a chances that there might be a production grade E10 or maybe a different combination between E10 and E20. So coming to calibration part, also this is kind of important to keep the end customer requirement in mind. So if we already know that there is going to be a compromise when we calibrate for E10 or E20, and this compromise will be made, also to be made keeping end customer in view. And we also need to already discuss on incentives, what we need to provide so that we can all be successful in overall making this overall success. So these are two important points what I would like to touch upon.
Thank you. Thank you. So we have, of course, discussed a lot of challenges, and Mr. Kumar, I think one quick comment on prioritization of different fuels, right? We have talked about coexistence of fuels in the country, but I'd like to get your perspective on this. How do you see India really rolling out its fuel strategy in the years to come? You're on mute, Mr. Kumar. You'll have to unmute yourself, please. Mr. Kumar, are you able to unmute yourself? No, we can't hear you, Mr. Kumar.
उसका डबल क्लिक करिए सर, अनम्यूट को डबल क्लिक करिए.
No, we can't hear you, Mr. Kumar. Can you see the panel on the right? Now it works. No, yes.
Now I think you are able to hear me. Yeah.
Please go ahead.
Yeah. my other colleagues, they have talked about consistency and availability of the ethanol in the market. Coming from the after treatment system, so I will be reserving my comments about that. So as we have seen in a preliminary studies carried out, the unregulated emission, aldehyde and formaldehydes, etc., are as a byproduct of the alcohols. So they need to be regulated. Like we see there is a good conversion, but we look forward to have some emission standard for the unregulated components. Once they are there, so we can see or define the challenges. And the elementary study which we carried out at our end, it shows that yes, E20 can be utilized in BS6 fuel because they are already closed loop and lambda control takes care of that. But yes, when OEM works directly or in detailing into it, they have to come across if there is any cold start problem, or if there is any acceleration problem or any other aspect of the vehicle drivability, they have to come across. And but as it looks, as a after treatment supplier, we can cover up that very well, and we can support in meeting the emission target, whichever will be defined in the near future.
Okay. Thank you, Mr. Kumar. I'll come to the second phase of this discussion, wherein I would like to more focus on the roadmap towards India's ethanol economy. What are some of the steps that needs to be taken to ensure we meet the set targets? So I'll start with you, Dr. Ray. We've talked about the possibility of, let's say, switching to environmentally sustainable crops for ethanol production in the long run. Now, looking at the targets that we have set, looking at the complexities that we have for all stakeholders, how feasible is it to do within the time frame that the government has given?
I think that's a very fair question, and it comes back to the point made on focus and prioritization that was brought up early. We can boil the ocean and get partial outcomes in everything, or we can pick a few bets first and do those well. So I personally feel that if we have a clear E10 and a clear E20 focus, we stand the best chance of getting a good rollout. But everything else can be kept as a parallel development, but not distract you from getting the E10 and the E20 rollouts right. That would be my view. Also, I think nationally, based on whatever data we are seeing, an E10 national availability has a better chance of giving all stakeholders comfort and confidence than looking at both E10 and E20 in parallel. So I would say E10 first and E20 in a phased manner, but making sure that E10 remains available as long as possible so that older vehicles as well as ethanol from streams where impurities may not be as precisely defined are kept down to E10. That's my very brief summary.
Okay. Thank you. Thank you, Dr. Ray. This is a question which I will direct to Mr. Singh, Anup, as well as Mr. Banerjee. The current two-wheelers and passenger vehicles that we have in the country are designed optimally for E5 compatibility, if I understand that correctly, while rubber and plastic components are compatible with E10 fuel. Now, to move to E20 compatibility, are we looking at a significant overhaul in terms of materials used or the ways or the way the engines are designed? I'll start with you, Mr. Singh.
Well, Dipanshu, the point is the biggest problem is a vehicle which are already on road. When you dispense the fuel of E20, you are not differentiating. Those people will go and fill the same fuel into that. What will happen to that? Those vehicles have not been designed for E20 compliant. If you want to design for E20 compliant, it's not a big deal. As I think Prashant also said, technology is not an issue, but we need a time and a sequencing. So at this moment, the problem in our hand is that E20 cannot go on existing vehicle, partially for a performance and majorly for a material.
Okay, thank you. Anup, your thoughts on the question?
I think we have to be clear about the objective. When you say how difficult is it to get to E20, we have to first define what is the objective. Are we talking about a vehicle which can run on E20? That means at least the material has to be compliant so that customers don't face issues from the perspective of say reliability and durability. So that's one level. The other level is, are we talking about vehicles which are compliant to E20 from performance perspective also? That's a totally different ballgame. Now, when we are talking about vehicles which are tuned for E20, E20 also comes with around 95, then it could also mean that you do compression ratio changes, you do engine level hardware improvements so that you harness the benefits of E20. Let's not forget that E20 comes with 8% lower heat content. Okay, so that's a loss to the consumer per liter. It's a loss to the consumer. So as a powertrain engineer, our endeavor and effort would be to recover that loss as much as possible and gain from the higher octane of ethanol. So for that, development is required. That's why we are saying let's do it in steps. Let's if ethanol 20% is going to be available from 23, so let's focus on utilizing that ethanol so that we make our vehicles compliant from material perspective to E20. But we can't do E20 fully compatible by this time. So we'll have to have another milestone where we improve our engines, where we are able to get the benefit of E20. And by that time, there should be enough clarity about availability of this fuel across the country, a common specification across the country. That is essential. That's what I said, that development is actually happening today. 25 level of development is actually happening in our labs today. So if this clarity doesn't come soon, then we would have already missed this bus as well. We lost this bus in BS6 when we wanted around 95, and now we'll miss this bus in 2025 as well. So I think it's very important that we have this specification charted out. We have a commitment written down on paper the way it was there in BS6 level, so that engineers can then work on it and optimize. I think that optimization work becomes simpler if clarity is there. So I think we need to focus on this clarity aspect for engineers to use this fuel. The technology development is not an issue.
Right. Dr. Malhotra, one question to you. The panelists here are very clear as far as technology is concerned. That is not going to be a barrier. But what kind of support? You talked about the industry coming together, working on this. What kind of support would the industry really expect from a regulatory standpoint?
I really don't know. What kind of support we can work together and try to convince the government and that the if E20 is guaranteed, and let us say whether if E20 from certain date is a reality, then auto industry can certainly go forward and develop the vehicles which will get the maximum benefit in terms of fuel efficiency by going for enhanced compression ratio and also doing the tuning for that. But I have my doubts that really we have been saying 10%, but we have been having 8%, 8.5%, 20% guarantee. But I don't know really, because if you design for E20, your high compression ratio and you don't get that kind of octane, then certainly you will have problems. But if you have vehicles which are designed for E10 and they get E20 fuel, of course there will be some penalty on fuel efficiency, but at least the performance problems may not be there. There will be quality giveaway, in a sense, that octane giveaway kind of scenario. But vehicles possibly, if they are material compatible. As Mr. Arjit also said, we are saying that the vehicles are material compatible but not the performance compatible. So performance compatible is possible only if guarantee is given. And guarantee can, I don't know really, we will have to talk to the various stakeholders, because there are some uncertainties also when you are moving so fast. Of course, 2G ethanol plants are coming up, and but I really don't know whether 20% guarantee can be given by anybody. Of course, there is a strong push for that, and there is a strong will from the from the government and also the various stakeholders who are working towards that. But if you say that it should be guaranteed, I don't know whether 20% at this stage, if you say that we will produce all the vehicles with E20 and you guarantee, I don't know. We need to discuss this further with the government.
Get that. Mr. Banerjee, you had a point to make on this.
Yeah, I just wanted to say that when the question you are raising, what kind of support government should actually give, let's be very clear. There is a saying that loose tolerances tightly held is always better than the tight tolerances loosely held in engineering parlance. So therefore, making a very ambitious targets which are actually not achievable, we should not make a mistake on that. So therefore, take a baby steps, but very confident step. When we are saying, as Dr. Ranjan rightly said, that if E10 pan-India, it gives a confidence. But then, in a our alacrity to introduce E20 in some pockets of the surplus area, we may make a mistake, because as already Harjit and Harjit San and Anup San already explained, that E20 is around 95, and if you get the compression ratio increase, the customer is the king. Actually, we should focus customer. He cannot move out of the surplus area, because if his engine is tuned to E20 with higher compression ratio, he cannot move to the non-surplus area where you have a E10 available. So therefore, my request would be what Dr. Ranjan has rightly said: make pan-India E10, and then E20 target if our 1G, 2G and grain conversion, supply chain network is such that we gradually migrate to E20 pan-India. That's the target 2025. But I think in the intermediate step, this transition, we should be very, very mindful of not confusing the customer and not making overkill of the technology, which will lead to E20 failure in longer term. We should not make that mistake.
Right. Thank you, Mr. Banerjee. For the want of time, I will come to a final question, which will be directed to all the panelists. I'll go one by one. It's the final comments from all of you essentially. Is ethanol the panacea that the environmental problems we face until the country is truly all electric? So is that what is being sort of focused at when we talk of ethanol? I can start with you, Mr. Kumar. Is this the right alternative?
Yeah,
right,
as we have seen, like
all electric.
As we have seen, like the ethanol blending reduces the CO as well as the hydrocarbon emissions. So that properties can be utilized. And again, the high octane number of the ethanol, if the consistency is there, then even OEM can optimize the engine for higher compression ratios to take the benefit of the thermal efficiency, as well as the higher latent heat of vaporization. That can also help in tuning or redefining the engine by advancing the spark timing, which will also enhance further the thermal efficiency. So along with the benefit on the emission front, one can even leverage for the higher or better fuel efficiency on calorific value basis. Towards the end, I will also add one point, like today in the country, we have a fuel system where the prices are changed very regularly. So system is in place. So a fuel price shall be based on the calorific value rather than the fixed value for E5 and E20. That's all.
Thank you. Mr. Ravindra, your comments on this.
Yeah. From opportunity wise, no doubt about it. It is, but I would like to emphasize one more point, because I come from also represent component manufacturers. So there are a lot of MSMEs. You know that it's very important that industry make a very clear long-term technology roadmap to enable to plan investment. Of course, no technology agnostic roadmap, and industry needs also a time to strategize and plan. So OEM and supplier will have to work together, close vicinity to bring this on road. So I would say that's more important, to have a very clear technology roadmap. Be it E20, whatever. So we need a very clear technology roadmap.
your technology roadmap. Dr. Ray, your final comments on today's discussion.
All right. I think I will just respond to what Mr. Dinesh Kumar said about pricing based on calorific value. I'd say pricing based on calorific value plus the carbon impact, the carbon tax or the carbon equivalent would be a lot more fair if you were to really value the value of ethanol on the environment compared to gasoline. I would just say that the less we intervene and the more we allow the market to determine price and value, focusing on standards and user experience, the more likely we are to have a success story. I'll leave it.
Right. Dr. Malhotra, your quick final comments.
You know, you asked that whether ethanol is the only, we have so many options available, ethanol, methanol, natural gas. All these are will complement and as far as the pricing, Dinesh said that it should be, and I fully agree with Dr. Anjan Ray on that, that the carbon reduction which is possible with ethanol should also be factored in, because ethanol is not going to be cheaper than petrol and normal MS, So it's not possible to price it lower than the normal gasoline, because your refineries will, or the oil companies will have to buy ethanol, which will be at a higher price when you are talking about 2G ethanol and so on and so forth. So the price issue is very complex. I don't think that you can be basing it on the calorific value. I think the carbon, which Dr. Anjan Ray suggested, could give a clue of that. But don't expect ethanol blends to be cheaper than the normal petrol.
Thank you, Dr. Malhotra. Mr. Singh, over to you for your final comments on the subject.
Dipanshu, I would like to say 4 or 5 comments consolidating the various pain point or the challenges what you have been talking about. I think a lot has been talked about uncertainty. We have also requested the government to please release a notification, at least it will have a binding on OEMs as well as on the oil industry, similar to what Anup Shah mentioned many times, BS6 norms, where we had a notification for the oil as well as OEMs, and we all work together to achieve within 3 years. So that's the first point. Second point on the customer pain point, what I feel today, customer is suffering a fuel economy of around 3 to 5% even with E10. So there should be some kind of a price differential. We have to find a way proportionate to the energy content. Somehow I do not know the mechanism behind it, but to a customer, if a less energy content fuel is being given, we should pay less for that. The third point is, we are worried about most of the existing vehicles which are in millions. And that is why we have been requesting government to continue E10 till the end of the life of the vehicle. And at least now the government has recognized this fact that the study has been launched. And I think outcome will depend on the study once we come out. But the next is most critical, which I've been also saying that E100 or E93, it doesn't help anyone. It is only in Brazil, and for a flex fuel vehicle or even for a fixed fuel vehicle, we should limit our maximum ethanol content to 85. The next, we have also seen there are pollutant difference with the various level of ethanol blend, because it's an oxygenated fuel, and we have seen normally NOx goes little higher, whereas CO2 goes down. And it will be first of its own kind that India will be meeting with Euro 5 equivalent BS6 norms. And we should have a small adjustment of this. I'm not saying reduce everything, give a relaxation of each pollutant, but we should have an adjustment which will come based on the research we will do it. And the last one is OBD2 challenge, which is nowhere on this globe, where two-wheeler are meeting with Euro 5, the OBD2 level. So we have been requesting for 1 year extra. We are only asking for extra time from 23, 25 to 24, 26. So this is where I'll sum up, Dipanshu.
Thank you. Thank you. Anup, I'll come to you for your final comments.
Yeah, thanks, Dipanshu. I think I would like to talk about 2 things. I think the pricing issue, which was spoken about, and then come to your the question about is ethanol a panacea till the time we see full electrification. I think two things. So as far as pricing issue is concerned, I think it's really important. May not be so important in the E10, E20 regime. We are still talking about 5-7%, but it's going to be a non-starter for flex fuel vehicles. I think if we don't have 35% lower prices for E100 for E100 or E85 for dispensing into flex fuel vehicles, then those customers have no reason to buy a flex fuel vehicle, a vehicle which is going to cost them more as an initial cost, and a vehicle which is going to cost them 35% more to run is definitely a non-starter. So I think that's a very important point to be debated and closed before industry can actually go to the development of flex fuel vehicles. Brazil, by the way, maintains this gap of 35% for E100 in compared to a gasoline fuel. So that's about pricing. Now coming to the main point which you talked about, is this a panacea for all the issues that we have seen today? As far as ethanol is concerned, today we are talking about blending this into gasoline, and gasoline is only 12.5% of our basket. It's two-wheelers and four-wheelers together. For passenger cars, it is only 4% of the overall basket. So whatever you do, you are only going to talk about this 4%. Even if you replace it by 100% ethanol, you are only going to talk about 4% of the total crude oil basket. So when you're talking about lakhs of crores spent on lakhs of dollars spent on crude oil, so when it comes to ethanol, so you're only talking about that 4% basket when of that. Greenhouse gas, as I said, 2.3% of greenhouse gas comes from four-wheelers. So from that perspective, both from greenhouse as well as from energy security, it's a small number. But that doesn't mean that we should not work on it. I think whatever we can do to improvise this. We are already working on fuel economy improvements for vehicles. 2017 was the first level for passenger vehicles. 2022 is the second level for passenger vehicles. We are doing that despite this 4%, despite this 2.3% contribution from passenger vehicles in India for greenhouse gas. So what if we are going to do this ethanol 20%? So it's going to augment our efforts to decarbonize. So it's in the right direction. And it's also in the right direction because today, for whatever we may say, electricity is not decarbonized. So it's even dirtier to run an electric vehicle probably today as compared to a CNG vehicle. And CNG is, by the way, another tool for us to improvise things, to decarbonize. It's a low carbon fuel. It's not carbon neutral, it's low carbon. But look at this revolution which is happening in India, where we are talking about bio-CNG, which is a carbon negative fuel. It is not just carbon negative fuel. That fuel is being produced from in a factory or in a plant which is taking local municipal waste and so on, and it is dispensing locally to a fuel station which is maybe 50 kilometers away, and where we would not have even thought that CNG is going to go in, where CNG pipelines would be laid. A local fuel which is carbon negative from any way, and it is going to be used for vehicles. It's a negative fuel that way. So I think we need such fuels. We need such diversification of fuel for passenger vehicles and for other modes of transport, even LNG for that matter. So there is no single panacea. It is about the objective. What is it that you want to achieve? You want to achieve greenhouse gas reduction. So let us work on these 3-4 options, which are complementing each other. It's not like you are doing methanol and ethanol, which to me is a difficult proposition. It's not a impossibility, but it's a difficult proportion, both for auto industry as well as fuel industry. So let's work on solutions which are complementing each other so that we are able to reduce the greenhouse gases, reduce the crude oil consumption, and so on. And
I fully agree with that.
Yeah. Thank you.
Fully agree.
Thank you. Mr. Banerjee,
No, Anup spoke very well. I think he has very rightly mentioned about several options which are available, and I think these natural gas, which is going to expand in a big way, needs to be promoted more than even the biofuels, which government is rightly doing. I think that's the way to go about. Very well spoken, Anup.
Thank you, sir.
Thank you, Dr. Malhotra. Mr. Banerjee, I'll give you the final word today. Please go ahead with your final.
Thank you. Actually, the question is ethanol panacea? Panacea for what element? Element of energy security, element of GHG reduction, element of local pollution mitigation, element for stress in the social systems, economy, component industry. If there is a complete disruption from A technology to B, then obviously the ethanol stands the best chance and best placement in Indian context. So I think what Government of India is doing is right. Pan India E10 with a very clear roadmap. Migration to E20 is the right move, and I think automotive industry wholeheartedly welcomes. And often Dr. Malhotra jokingly says that with ethanol promotion, the IC engine life goes on. It gets breather. So therefore, the question of electrification, migration, dependency to hostile countries, import, those issues will not be there. So in all, I think ethanol economy and increased use of ethanol in transportation is a very right step forward. The only what is required to be done is take the very confident baby steps, but all the policies must give a consistency, stability, and clarity. With these words, I would like to comment on behalf of auto industry that there is unflinching commitment from industry to align with the government's objective. The only need is that please help align all the standards at one go. As you know, that powertrain development happens simultaneously. At one place we do fuel efficiency, at one place we do the emission, the same place we do other important. So milestone should be accordingly placed properly. Thank you.
Thank you, gentlemen, for being such a wonderful panel. I think very clearly, like you finally summed up, Mr. Banerjee. The industry welcomes it. Of course, everyone is seeking more clarity, and once we have clarity, it is important that we have a stable sort of policy implementation going forward. I don't think the discussion on ethanol can end with a 1-hour discussion like this in a panel discussion. There would be, but this is a great start, and I'm sure there will be many, many more discussions on this subject in times to come. Thank you once again for being a wonderful panel. It was wonderful to moderate this. Appreciate it.
Thank you.
Thank you.
Thank you, Devashish. Thank you.
Thank you.
Thank you, Mr. Dipanshu, for wonderfully moderating the session, and thank you for all the panelists for conducting and giving us a very beautiful panel discussion today. And we are very grateful for your valuable time. I know we have spilled off on time a little bit, but thank you very much for your patience and bearing with us at this time. And we'll be now ending today's sessions. And tomorrow we will be joining again at 2 p.m. And we will be joined by international experts tomorrow. And we would request your presence with us tomorrow. And we have a panel again, a session on international experiences on ethanol blended petrol and diesel tomorrow at 2 p.m. And there will be presentation by Ms. Susanna Paz from Apple, Spain, and we have Mr. Ryuto Nimura from Honda, Japan, and Dr. Richard Osborne from Ricardo, UK, and Mr. Srisant from Volvo, and Mr. Attilio Siani from BASF, and Dr. Paul Kapuz from AVL Austria, and also from Mr. Saurabh Banerjee from IOCL. So we have a lot of experiences which would be shared tomorrow with us, and especially international experiences. We would all look forward for your presence tomorrow. So thank you very much again. See you tomorrow.
Thank you.
Thank you. Thank you.
Thank you. Bye-bye.